So I decided to do something different to change my plans. At least for now, I'm not sure if I'm gonna keep it like this. But the idea is to learn Rust and Vim. Vim, I actually think I'm definitely gonna learn. It's gonna take some time. I'm gonna do 30 minutes every day, I think, of the bindings until I get used to it. And I'm gonna try to use it on VS Code because I think that is one of those things that is just really hard in the beginning, and then once you get used to it, everything becomes easier. And I think all of the people that are good at coding are very good. They know Vim, so it must be. I don't think it's like a very big deal if you don't know, but it probably helps. There is like the small things that make a difference on the aggregate that you don't realize day by day, just like eating healthy or meditating, but those things compound over time. And I think Vim is probably one of those things, so I have to learn it, regardless of how difficult it's gonna be. And I've been resisting this for a little bit, so I think I'm gonna just do this every day until I learn it. And then Rust is also something that I wanted to learn. I don't know why, it's just an intuition. Uh, Ever since I did the course on Zero to Mastery about Rust, I thought that it was a really interesting language, and the benefits is that it's a lot faster than Python. Python is good too, but for the things that I want to do in the future, I think it makes sense to learn Rust. I mean, I will see what happens depending on whether or not I can do it on the using Windows, because I don't want to use a virtual machine just for that, because I find it really annoying to open the virtual machine and the virtual machine is slow. And maybe I can use WSL, Windows Subsystem in Windows and learn like that, but I also don't like that because then you have to separate the projects on different computers, and it just becomes another thing that to worry about or to think about in the design of the overall thing that I'm doing, which is maybe something that is worth doing in the future, but now since I don't have much stuff, I don't think it's worth it. So I think the condition is going to be, because I haven't looked into it yet to see if I'm going to be able to do. I remember that when I was learning Solana, I was also learning a little bit of Rust, and I remember I couldn't do it in Windows, but it was because of Solana and not Rust. So Solana requires a library called, or a framework called Anchor, which is similar to Hardhat if you wanna code smart contracts. And that framework doesn't work on Windows, at least for now. So I had to install the virtual machine and build the things on the virtual machine, but eventually I ended up quitting that because I had other stuff to do. But I don't think that there's anything that's gonna stop me from coding in Rust using Windows. So, and then my idea is gonna be eventually to find a different blockchain that accepts Rust as well. Hopefully Solana, if I manage to figure out a way to use Windows, because Solana is the biggest one. It's also very cheap, and there's a lot of people that use it. It's cheap to make transactions. So I want to get data from other uh, blockchains as well, not just Ethereum, because I want to have something that connects everything and gives me a vision of the overall market. And also, the major thing that made me want to do this of learning Rust is that I was studying how to analyze the data faster with Python, because I wasn't being able to read the data frame because I ran out of memory, because the data sets that I have are really, the data frames that I have are really large for analyzing all the blocks in the blockchain. And I didn't even get the whole history of the blockchain. I got half of it, and split between data frames, and it's already 200 gigabytes, one of them, the highest one for transactions. and that data frame is really slow, or it doesn't even open with pandas, and with the VX library is really slow. So I was looking to see if there are any libraries that are faster, and there's a bunch of different libraries I found out that I didn't know about, and there's a bunch of different metrics. I didn't go too much into that. But one of these libraries is called Polars, and it seems to be one of the best ones and the fastest ones. And I read the article of the guy that built the framework. Uh, It's actually not a framework, it's a library, but he built the library in Rust. So, and it's also something that I've been wanting to know for a long time because I want to get closer to the way that the computer actually works. So things like managing memory and understanding the stack frame, understanding the heap, how these things connect, I think is really important. But it's really difficult as well in the beginning, and that's why I have resistance. So I know it's gonna be very, very hard in the beginning, and that's why I didn't want to do it because there was so much other stuff that I had to learn. But now I feel like I'm at a point where I can afford to do that because the stuff that I have right now is probably already enough to find a job, especially if I study more. And um, by the end of the year, I think I'm gonna be ready to search in case I need it. So, yeah. So I think that's. I was gonna say something else that I forgot. But yeah, I think that's the point. Rust is gonna allow me to understand better how the computer works and be able to code things that are faster. And I'm thinking about using it as a pipeline to extract the data and to make analysis on Rust. Or if I can't do the analysis, well, actually, I'm gonna try to do the analysis because it's just mathematics at the end of the day. So even if I don't find frameworks like pandas that allows to have different methods, I can just code the functions because it's simple mathematics. But I think there's gonna be not even mathematics, but you can. It's like shifting lists or arrays or vectors or things like that. So I think all of these things are gonna exist on Rust in order to manipulate the data, clean the data, do all this kind of stuff. And it's gonna be a lot faster than Python. And then once I do all of this stuff, then when it comes time to put train machine learning models and thinking about that part, then I'm gonna move those data frames into Python, and then I'm gonna figure out to create machine learning models on them with Python. So that's the plan. But that's gonna be, I think it's gonna take very long time for me to be able to create different machine learning models and get to that point because the first is, and is not an easy task, I think, is gonna be to get as much data as I possibly can from different blockchains and understand how all of these blockchains are connected to understand the ecosystem and to also understand how to get a bunch of data and understand complex patterns like I'm trying to do. And this is not going to be easy, I think. So yeah, that's the plan for now. And I didn't want to learn C++ because I already learned the basics, but I think Rust is going to be better for the thing that I'm trying to do. And it's just a language that, for some reason, intuition, something like that, uh, something tells me to learn it. So I think is from what I've seen, there aren't a lot of jobs on Rust, but it's gonna grow in the future for sure. And some blockchains use Rust as well. So I think I can integrate it really well. And I also have the project that I'm doing, which is gonna be a good way to integrate that. I'm gonna try to build, not gonna try, I'm gonna build it with Rust, at least the data frame, getting the data. I already saw that there's a library for Web3. So I'm gonna get the data on Rust and then do that stuff. And while I do that, I'm gonna learn Vim as well. So probably what I'm gonna do today is just watch a bunch of videos. That's usually what I do when I'm learning stuff. First, I watch lots of videos, lot different videos, so I have an idea. So it's like the superficial level. I have an idea of different libraries, how people usually search for information, that kind of stuff, and it's on my subconscious mind. And then once I get the beginning, I still like don't really learn that much by watching videos. I'm still not gonna be able to code everything myself, but at least I'm gonna have an idea of the back of my mind of how usually I'm supposed to structure things. Because I know in Rust there are different things that don't exist on the languages that I'm used to, which is Python and JavaScript, and even C++, which is enums, structs. Actually, Solidity has enums and mappings, and also has structs, but I haven't used those data types enough to be able to understand when to use them and when not to use them, and the design of the thing overall. And also know by now that in Rust you don't have inheritance, so I think it's more of a functional programming language, but I'm not really sure. And I also understand that you have memory borrowing. You can borrow things, and every every variable that you declare is a constant. But there's also the const keyword which you can use, which makes slight differences on the way that you declare the variables. I also know that the string is a little bit different than in other languages. I don't know why, but it seems to be something. So these kinds of things, I think it's good to watch videos first, just to have an idea of how it works and what's usually the paradigm and the pattern that people use to build stuff on the language. And it's the same thing that I've done for Python, JavaScript, Solidity, and C++. But I couldn't find so far a good resource to learn interactively. I was watching this guy's YouTube channel,
Welcome back to Let's
this
Get Rusty.
guy here. Watched a bunch of videos, and he recommended some stuff, but I didn't go too much into it yet. Yeah, so my plan now, actually, let me stop the timer because I'm not really training. My plan now is gonna be watch all of these videos, maybe code along the way, just some small stuff to understand how it works. Then I'm gonna watch. These are videos that this channel got recommended by this guy when I was watching some of these videos. And this is supposed to be more advanced tutorials for Rust. There's also some live streams that that he did apparently, which shows himself building actual stuff, and he seems to be very good. So what I'm thinking about doing is going over these tutorials here, just watch all of them from this guy, and then once I have the rough idea, then I move on to the more advanced stuff. Then I get the sense of like the end goal, how people usually build, how people that are building, that are advanced, are building stuff. And then after that, I go back into more the easier stuff, which is either the free code camp or this guy here. And then after all of that, I think I'm gonna watch this one as well, which is this guy reading this book here. And yeah, and I'm gonna do this as long as it takes. Hopefully, it's not gonna take more than 4 days or 5 days, but if it does, no big deal. That's my plan, and I'm gonna do this for 30 minutes every day as well, which is a website that is interactive and allows you to learn Vim. Uh, allows you to learn the key bindings of Vim. So I need to learn at least the basics so I can move around the thing without getting completely lost. And there are different levels as well. I'm on the beginner one. If I have to pay for the advanced ones, I'm not gonna do it. I'm just gonna get a cheat sheet and do it on that. But yeah, I'm gonna do this for 30 minutes every day and then watch the videos until I feel like I'm able to at least do something or understand how things usually work. And then after that, I'm gonna start building something to get the data from Web3. Beginning of the line, takes 0. I already did a bunch of this, so I remember some of them. But it's still not automatic. Beginning of line, 0. At least I remember all of them, despite not coming right away. I wonder if this is gonna actually help when I call though, but I guess we'll see. And it's really annoying, this first part, the beginning of everything is usually really annoying because you don't know anything, so it kind of sucks. But that's like most things that actually have any benefit. Usually the beginning sucks, then you raise the standards and you get used to doing them, just like working out or anything, or learning anything. And I think that's a good principle to have when you know you're in the right path because that means you're getting out of your comfort zone and you're pushing yourself to learn more. And that's how you grow fast, I think. Definitely, your brain doesn't want to do it because it's going to create a bunch of different reasons for you to rationalize so that you stay on your comfort zone. first line. And depending on the price of this might pay, to be honest. If I find out that it really helps me, because I like this style of learning, I think it's very effective. Spaced repetition and the way that this is. So far, I think is the best site that I found that is interactive. The other ones I didn't like that much. There's a game you can play, but then it gets into other stuff that you have to figure out how to move on to the next phase. And I don't think, I think that's just a waste of time. I didn't like it that much. And then there's another site where you can move around, but there's not no really goal or anything to do. So it's kind of hard to create a structure around it instead of just clicking the keys and seeing what happens. Yeah, 800. Last line of the screen. Uh, I think uh, you need probably 10,000 repetitions until it becomes automatic, probably. But that's over a space of time. So maybe I'll go to the next key bindings once I reach 10,000 on this one. But it might not be necessary to hit 10,000 on each set of these key bindings. I think I can do it with less and then. But I just want to make sure that before I move on to the more complex key bindings, I know unconsciously the basic ones first. So it's always better to have a strong foundation before you move on and to be patient, I think, because those mistakes compound over time, I think, in everything. So the fundamentals is usually always the most important thing and the thing you should spend the most time with. And then the rest you can learn faster, I think. I knew that one. Just got the thing wrong. I think I'm starting to get it. The end of the word always confuses me with the next word. Maybe I should test this stuff. I think I'm gonna test it actually to see if it is actually correct. Because I also know that if you train yourself in the beginning with the wrong patterns, it becomes much harder later on to do this stuff because you already have the neural pathways used to that pattern. It's not irreversible, but it takes a lot more time. It's just like typing, where initially I learned the wrong way, and then I had to go back and learn touch typing again. And I learned a lot faster touch typing because I already have trained the other way, but it still takes a lot more time than necessary. Let's say beginning of the word is B. Okay, works. Which next word? Slavio. Okay. Last line of the string. Yeah, this one is not working. Control L. Oh, it's Shift L. It's working. Yeah. I'm just messing it up. Left one character. Is H. Yeah, left and right, up and down. I think I already got it, but the other ones I'm not really sure. And this is B. End of the words. Okay. Okay, so it works. And up and down. Oh, why? What? Why is selecting everything? Maybe I pressed something different. Yeah. Okay, so E works. B. Say end of the line is Control Shift Shift this. Beginning of the line 0. What else? I also confuse a lot the up and down when I'm moving fast. This is something I have to work on. It's not that intuitive to me. It's more intuitive to me if the down was on the right finger. But yeah. What other ones? And the word 0 was not going to the beginning. Mm. Mm. It only works for words, I guess. Let's try 0. No, works 0. I don't know why it wasn't working there. Yeah, I definitely think that this is gonna make me a lot faster, to be honest. Because I remember there were several times when I was working on other projects and it was just really slow to select things and then move things around. It's probably not that big of a difference, but I think it makes a lot of difference when you count everything. over time, all the instances where you would waste a little bit of time, I think it adds up. First line of the screen. Okay, works. Yeah, I think they're all correct. There isn't any other. Maybe M. I didn't ask yet. Yeah, Shift M. Okay. Oh, okay. Down one line. Next words. Last line of the screen. Up one line. Okay, nice. 10,000. Meaning of line. It's just difficult as well because you have to learn this stuff while learning how to code, so it can be overwhelming. I think it's gonna be a little bit overwhelming in the beginning because not only I have to think about Rust, but I also have to remember all these key bindings. But it looks like I already memorized all of them. It's just not coming naturally yet. I think it's not gonna take a lot of time to, given how easy it was to memorize these first ones. But obviously, when I get to a place where it's just automatic, I don't have to think about it. I think 1 week probably is gonna be enough for the initial keys to get to that place. I knew that one. Fuck. The beginning of the line is still a little bit hard to remember. I could probably code something as well to train interactively, but I think it's just a waste of time, probably. Almost over. You could remove this move, sure. Here, it's kind of annoying. That no big deal. Yeah, typo there. Last one. I got three of them right, and then I'm gonna stop. And maybe. Okay. Yeah, I'll be right back. Also think I'm gonna pull up the stuff from the Turing. It's gonna help. It's probably important, the stuff that they were asking about. Yeah, I might study this stuff as well after I'm watching
and
all
kind
of
of space
these
out some of these outputs.
videos.
So cool. We know that that's going to just print that out in raw form. What about if we wanted to actually, what do we want to actually do? Well, let's start by asking if they want to send or receive Bitcoin. So do you want to send S or receive R Bitcoin? And I always forget about this, but do not forget the semicolon here. Usually the IDE will catch you, but Rust is very particular about semicolons. In fact, in a future video, we're going to cover the omission of a semicolon. If you purposely leave it out at the end of a function, that's actually how you do a return. Like you don't have to type the keyword return if you just have no semicolon. So kind of neat. We'll cover that later. But remember to include that most of the time, all the time right now until we cover that. So to start out, we want to take the user's input, whether it's an S or an R, and we want them to dictate what our app's going to do, right? So let's say let command equals string new. So this is how you create a new string. We've got the string struct, and then we're using a method from this struct called new to initialize a new string object. And we'll cover structs later on. So what we're going to want to do now is overwrite this value with the user's input, and they're going to ideally put in an S or an R. Now, in order to overwrite this, right now, this value, by default, when you use the let keyword, which is how you find variables, and nothing else in here, by default, this is going to be immutable. So you can't change it. In fact, if I try to go down here and say command equals,
I think I'll go faster through the basic stuff because I already watched a bunch of videos and did a course on Rust, so I kind of know the basics of it. And then I'm gonna try to go at between 2.5 and 3x speed. And once he talks about something like implement or EIMPL, which is a special keyword, or struct or enums or that kind of stuff, I'm gonna slow down a lot because those ones I have a hard time understanding.
let's just do like string from, and this is how you create a string from a small string select or something like that. Let's just say like Homer. Rust is immediately going to say, hey, you can't do that. Well, actually, it's telling us that it's never being used, but the real error there is that you can't just overwrite this because, see right here, you can't assign twice to an immutable variable. Now, all we have to do to make it mutable is this. Just add that mute command or keyword. You have to explicitly tell Rust that variable is allowed to be changed. This is part of like the benefits of Rust is you have to be very explicit a lot of times, but it saves you a lot of trouble in the future. It can prevent a lot of bugs by being very explicit about your instructions. So anyway, now that this is mutable, we're going to overwrite it with the user's input. So this is the function to use to do that. It's this IO object here. We're going to use stdn and read line. And we're going to type that and sign, mute, and command. Now, we're going to come back to this in 1 second, don't worry. So the first error we're seeing with Rust is it's saying this is undeclared crate or module. So in other words, it doesn't really know what this is. Luckily, as part of Rust's internal library that comes default with every program, you get the std library, and you can use stdio. But how do we import this? Well, a lot of languages the keyword is import, but in Rust, it's just going to be use. And you can see that error right away. So we're going to use this module, this package, and we're going to read user input with it. Now back to this. So what is this thing here? I mean, you can see the stdn is going to create an input, and then we're going to read the line from the user. Makes sense, but what is that? So basically, what we're doing here, and this is a little bit more complicated. We're going to cover a couple videos from now, but we're making a reference here. Now, in this particular case, we are referencing the mutability of this variable command. So essentially, we're checking with Rust right now, saying, hey, remember earlier when we said that command was going to be mutable? Well, here we are making that change with this function. And Rust is saying, okay, cool, no worries. So that's all that is there. In a video ourselves for now, we're going to cover references and borrowing. It's a really important topic, and this will become a lot more clear. But regardless, we're going to just mutate command with the user input. Sweet. So we said that we want them to enter an S or an R, right? So let's check to make sure that they've actually entered one of those values and handle it if they don't. So here's the first look at conditional in Rust. And we're going to say if command, we're going to trim it to get rid of any like new lines or anything that get generated from the user input, equals .eq S. If it does, we're going to do this function send Bitcoin, right? If it does not, if instead command.trim is equal to eq R, then we're going to do receive Bitcoin. I really think I'm going to spell that wrong. Else, if it's neither S or R, then we're going to do is just this exit console function. So as you can see, we're taking the input from the user and then we're comparing it to either S or R options. And if it's neither, we're going to do this little exit console. So these are all going to be functions, obviously. Let's go find those. So for starters, we'll do send Bitcoin. And we're going to come back to this one, but I guess we'll just put something up there right now. We're going to do also receive Bitcoin. Put something in there as a placeholder. And then lastly, we're going to do this exit console function here. And this is going to be pretty straightforward. All we're going to do is just print out invalid option. It must be R, S, or R. And we're going to put those in some parentheses there. All right, cool. So exit console, we just wrote that. Receive Bitcoin. So how do we want this to work? Get this out of the way for a sec. Well, if we want to receive Bitcoin, we pulled that random number generator in here so we'd be able to use it. So let's make use of that and let's just write a function that's going to send us a random number of Bitcoin. I think that would be pretty nice, right? So anyway, here's what we're going to do. We're going to do a print line and we're going to say we're going to receive some Bitcoin. Awesome. Line separators in there. And now we're going to do let amount equal. And here's where we're going to use that random module there. So what we want to do is actually add to our use statements. We're going to use rand and we're going to use the RNG attribute. So just like that. And now that that's being pulled in, we're going to say let amount equal rand thread RNG dot gen range. And that range is going to be from 1 to 10. Nice. Okay, so that's going to give us a random number from 1 to 10. And all we're going to do is just print out this statement that says you just received. And here's how you pipe a value in a string when you print it. You just do these curly brackets. We're going to finish our string, Bitcoin, and then a comma, amount. Nice. Beautiful. Super cool. And then our last function up here is going to be send Bitcoin, but we're going to come back to that in a sec. So for now, we're just going to put in like a bogus print line, like hello, you know, something like that. And we're going to take a look at what happens with this function we just wrote here, this receive Bitcoin one. So let's go down and run cargo run again. I'll open this up. And if you take a look down below once this finishes, there's our question. Do you want to send or receive Bitcoin? Let's go ahead, since we didn't do send, let's try to do one that's not in there. Let's do a G. Invalid option must be SR. Sweet. Okay, let's try again. Let's receive it. You just receive 7 Bitcoin. Woo, wow, 7 Bitcoin. Holy moly. Let's do it again. 7 more. 9 Bitcoin. 4 Bitcoin. So our random number generator is working just fine. That's good. Good to see. Now let's go back up.
Why not touch out to do macro as placeholder instead of whatever he did? I have no idea, man. I'm very new. I don't know anything about Rust yet. Just the basic, very basic stuff, syntax, and Yeah, but I'm gonna watch all these videos just to learn how to do it. So I don't understand anything yet. I think that is better and more idiomatic or idiomatic, and perhaps much better to learn early on. What do you have channels that you recommend for beginners, from beginner to advanced? My plan is to watch a bunch of videos first, and then I have a project that already had the project from early on, and I'm just gonna add some Rust stuff into it, getting data from Web3, and then analyzing that data, and then yeah, doing more stuff later on. But my plan is just to watch all of these videos. I have several YouTube channels here that I found just by searching. And people told me that this guy is really good. He teaches advanced stuff, and the other ones are more for beginners. So I think I'm gonna do a combination of them. And there's also this book here, and gonna watch this guy reading the book. But I know it's very hard to learn from what people said, so it's probably gonna take a lot of time. Oh, no worries, man. Okay, so I'm gonna
And let's write this
continue
send
to
big one.
watch.
So again, just like this, we're gonna add this print statement here as header. Instead, we're going to send some big.
Yeah, so but that's my idea because I like to. There's a principle from this book called Seven Habits of Highly Effective People, and one of these principles is begin with the end in mind. And usually, when you begin something, there are things that you don't know that you don't know. So I think it's very good to look at the advanced stuff for a little bit, even though I'm not gonna understand anything, because then at least I have a clear direction of where I should go and what things are important. I also have a list here from this website called Turing that they do tests. They help people get hired, and then they test you on a bunch of stuff. So I did one of those tests. I did a bunch of them actually, and one of them is about Rust. So I wrote down a bunch of things that they are asking for, and I'm also gonna search this stuff here. And I think that's a better way to learn than should not be aware of the advanced stuff in the beginning.
Bitcoin. Sweet. Now, let's just have a little fun here, and let's come up with a list of clients. And we'll send Bitcoin to one of the clients. And we're going to make sure that the user only picks someone that's in our client list. So we're going to work with conditionals again, and we're going to get a taste of a collection called vector. So let's let clients equal vec macro. We're just going to turn these entries into a vector. Now, a vector is very, very similar to a list. And for the example today, you can literally think of it as a list for right now. We will cover vectors in more detail later. But for right now, just picture this client's object as a list of strings that represent our clients. And as you can see, here's 6 characters. Awesome. So now we're going to print out the question. Who do you want to send Bitcoin to? Get a new line going there. And we're going to just print out each of our clients. So we're going to say for client in clients. And we're going to print. We're not going to print line. We're just going to do regular print. We don't need to necessarily see the lines between each of them. And client. And then we'll just print a new line real quick just to have things nice and organized. Now you can see that and sign is popped up again. So what are we doing with it this time? Earlier we were referencing the mutability of a function as we change it. But here we're using it to reference a vector. Now we're going to dive into this concept in the future in a couple of videos from now. But what this is doing right now is referencing the value. So rather than pull in this particular value and all the details about it, like its position in this vector, what vector it lives in, this and that, instead all we care about is this value because we're just doing something like a print or like sometimes we might want to create new variables based on that value. And we'll get into all the logistics of that. But this is what's called borrowing. We're just borrowing that value so we can run this loop and print all the values out. But we don't need the whole vector itself. We just need the values of each of these things. So like I said, we'll get into that more in the future. All right, so now that we're just printing out our clients list and the user's going to be able to see who's available to send Bitcoin to, we're going to take their input just like we did down here. So you can literally copy paste this. I'm just going to put this together so it's a little more concise. And it's going to be the exact same function, right? But instead of command, we're going to just change it to recipient. Okay, so it looks exactly the same, right? We're doing IO, SCD, and reline. We're making it mutable. We're using that reference to the mutability to override it. Beautiful. But now we said that we want to be able to check if the user's input matches who's in our clients list. We can't just send Bitcoin whoever we want in this example. So we're going to write that conditional check here. And we're going to say clients.contains, and then we're going to say reference that recipient value, trend. So we're comparing it. We don't necessarily need to pull in that whole recipient string, right? We just need the value. Again, we really only need the value of the string. We don't need the object itself. So if that's what we're going to compare, then let's say, okay, if this becomes true and that entry is inside our clients, we're going to continue with the application. So we're going to do a print line. We're going to say how many Bitcoin do you want to send? And then we're going to take the user's input again. We're going to take the user's input yet again in the same fashion. And this time we're going to call it amount. Right, so now we're taking the input as a recipient. If they match someone in our clients list, we're going to take the amount from the user, and then we're going to send some Bitcoin. So our final print statement is going to look like this. We're going to skip a line and say you sent blah Bitcoin to blah. And now we can declare that we want you sent amount Bitcoin to recipient. Sweet. So now this is great. We're double checking that this matches who's in our clients list, but what if it doesn't? Well, it's pretty easy. It's just an else statement. And if it doesn't, we're going to print blank is not in your contacts. And then we're going to go down and type recipient string again. So it's a nice string representation. And that should do it. So let's just take a quick overview. We already saw the receive Bitcoin function. I'll space these out a little bit so it's easy to see. And we're driving this console function from main. We saw send Bitcoin, we saw exit console. Or sorry, receive Bitcoin. Sorry. Now we're going to look at send Bitcoin. So let's save this. Let's make sure everything's working properly. Scroll up a little bit, it's a little bit bigger. And cargo run. Let's have fun with Bitcoin. Sweet. All right, so again, if we try that, there's something invalid. Cool, still works. And then let's receive because it just feels so great. 6 Bitcoin, rich. And now we're going to send it. Who do you want to send Bitcoin to? And there's our choices. Let's go with Homer. How many Bitcoin do we want to send Homer? How about 2 Homer? You sent 2 Bitcoin Homer. Awesome, awesome. And now one thing we just want to do is we can do that amount trim. You can see why we've been adding trim everywhere. Because it often will come up like this with broken lines based on the entry. So we'll add trim. We'll try that one more time. We're going to send to Bart 5 Bitcoin. Much better. Now let's do that again and try to send it to someone not on the list like George. George, now your context. Awesome. So everything's working properly, and that is pretty much how you build a basic program in Rust. And we covered a lot of stuff already. We've really only scratched the surface, but there's some really good nuggets in here. And going forward, we're going to break things down, like I said, at a granular level. And you're going to understand everything you saw in here. And if you want to code develop on GitHub, there's a link in the description. But I encourage you to follow along the playlist and learn how to write Rust. Hey guys, welcome back to the Rust beginner tutorial on coding crypto. And today we're going to be going over the basics. And we're going to go over the basics for the next few videos. So we're going to just do cargo new, the basics, get a new project going. And we're going to start with primitive types and some of the type rules that Rust is going to enforce on you while you're programming. So we'll just leave this as a hello world for now. And so for starters, we mentioned this before in the previous video, but you can't overwrite an immutable variable. So what does that look like? Well, if you do let x equals 5, and then you say x equals 6, Rust is immediately going to get mad at you. So you cannot assign twice to a mutable variable. Pretty straightforward. Next, if you want to overwrite a variable that is immutable, you're going to have to use the let keyword. So let's overwrite that variable and see what that looks like. Let x equal 5, and I'm going to say let x equal 6, and that's completely acceptable. Cool. Moving on, you also can't mutate a variable's type. So if we just do a little mutate type function, and we originally initialized a string, and now just as a little side note, because we're going to be talking about this in a sec, this is not declaring a data type. Rust is implicitly knowing that it's a string. In this case, it's actually a string slice, just because of what you're typing here. But we'll get into that in a second. You can actually declare data types too, but this is going to be a string slice. So if we try to take that value and we try to make it, let's say the length of it, which is going to be an integer, you can't do that. So mismatch types can't do it. And then moving on now, if you want to do that and you want to mutate the type, all you have to do is use that. Oh god, I can't spell mutate. Is use that let keyword again. So we're just going to do overwrite type, let, and I'll do a little copy paste for you guys. So you don't have to watch me type all this out. See? Totally cool. As long as you use let. So basically these four examples here are telling us that let is going to be how you tell Rust that we're setting a new variable. If you use the same name, it's going to overwrite it. And this is key to Rust compiler and storage of your application, mainly the stack and the heap, which we're going to talk a lot about. And I encourage you to understand sort of at like a technical level if you want a little bit more value of what some of these things are doing for your application. You wouldn't hurt to go and take a look and kind of see how the stack and heap work. Because we're not going to go into super good detail on that. We're going to just talk about how it relates to Rust. So anyway, as I mentioned, we haven't actually declared any data types yet. This has all been implicit. So every time we've done this or this, Rust knows by what we're typing there what the set is variable equal to. So you can do it that way. You can code that way if you want. However, a much more common use case is going to be to declare your data types. So if any of you have ever written Java, you're going to know exactly what this is all about. You're going to want to declare your data types in Rust mainly because it's best practice, but in Java you have to. So in Rust you have the option, but I gotta say it's a lot more helpful when you declare your data types. At least where you need to, so you can kind of go through and you can see exactly what each thing is supposed to be, and it helps you prevent those like mismatched data type errors. Just a suggestion. This is what it looks like though. Right in front of your variable, right after you put this colon here, and we're gonna make this a U32, which I'll talk about in a sec, and set equal to 20. So pretty cool. You can do it inline without too much more text. And what this U32 represents actually is this is one of the integer types provided by Rust. So we're gonna actually talk about integers. And integers can either be signed or unsigned. So if we do let signed int and we do I, these are signed integers. And you can see it goes 8, 16, 32, 64, 128. Those are all different size bits you can have for an integer. So let's go with 64 for now and set equal to 34. Now, same thing with unsigned. We do unsigned integer, you do a U, and so you got the same options for bits. And we'll do U32 and we'll make that equal to 11. So cool. That's how you do integers in Rust. Booleans are actually pretty straightforward as well. If you've ever done any kind of programming before, it's very, very similar. Booleans are kind of a simple kind of design, but the one thing to take note of here is Rust actually uses the lowercase kind of representation here. So some languages have capital T there, capital F for false. Rust is going to do lower. As so. Now let's talk about some strings. So if you might have picked it up in the last video, good for you. But there's obviously some complex.
One thing that I'm gonna search that I kind of struggle with is understanding or remembering how many digits can hold, and what do I do when I have a very large number that I want to store? Because that's something that I never have to deal with in Python or JavaScript. But I imagine there's something going on under the hood that converts all these types, and this is going to be really difficult if I have to explicitly tell the types. I'm not used to that. Also, this is a really large number. It's on the trillions. So probably it's very unlikely that you use anything beyond 64. I'm gonna think about different ways to search for this later, I think. What happens if you have a number that doesn't fit in 64? Yeah, there's probably a library for that. And maybe I'll have to use that library since I'm going to deal with Web3 stuff, because in JavaScript at least you have to convert from meters to arrays.
So there's actually a difference between strings and what we call slices up here. So this, where it's declared without any kind of object, it's just a raw string here. That's called slice. So let's create a slice down here. And you saw this already. If we just go ahead and do this with an inline string here, this is a primitive string, this is a slice, like we said. If you want to declare the data type, it looks like this. Now, don't worry about the unsigned just yet. We're going to talk all about that and borrowing and referencing in the next video. But for now, just think about it like this. This is how you represent a slice if you want to declare one as a variable. And then if we say let some string, and we set the value to a string data type, we're going to do string from, and we'll do donut again. So super important. This is a slice, and this is a string. Awesome. So as you can see, that can be kind of tricky because if you try to do operations, some operations like comparing and different things like that, you'll get a data type mismatch error. Even stuff like print behaves differently. And so it's really important to distinguish between those two things. And as we go further in these tutorials, you'll see plenty of that and you'll understand exactly what I mean. So the last thing we'll cover are going to be constants. This is how you declare a constant in Rust. And wherever you declare it determines the scope of the constant. So we're just declaring it here without being inside any kind of function, so it'll be available to the rest of the program. And I'm going to make it U32 and go with 20 again. So that is really it for primitive types right now.
Yeah.
In the next video, we're going to talk about borrowing, and we're going to talk about the sand symbol, and talk about some of the magic of Rust data types and some of those rules that we covered here. So thanks for watching. Hello everybody, welcome back to the Rust beginner tutorial on coding crypto. So today, as we promised before, we're going to be talking about borrowing and references and dereferencing, which is kind of like the penultimate rule in Rust, like one of the biggest things that sets it apart from other languages. Sure, we've got variations on different data types, different object styles, ways of like writing certain syntax, but this concept of references is going to be the difference maker, the number one reason why Rust stands out. So we're going to dedicate a whole video to it right now, and we'll start by demonstrating what is a reference. So we'll just do an example function here, function references. Now, you've seen this operation before, but let's set this original value as I32 equal to 20. Okay, so nothing out of the ordinary here. Now, we've also teased this a little bit. Let x equal reference original value. Now, what does this mean? I alluded to this in a previous video, but what this and sign means is we are going to borrow the value. So to borrow value, you conduct a reference. So I'm going to put the and sign is a reference, and when you reference something, you borrow its value. Pretty straightforward. So I add that in comments as we go, borrow the value of original value. Now, to understand borrowing, we have to take a look at how the memory works in particular applications, especially a Rust application. Now, this is my very haphazardly thrown together diagram of a stack and a heap. So don't worry about all the intricate details. I encourage you guys to go take a look at how the stack and the heap work to get some more context. But I'm going to give you a quick overview here so we can understand how this relates to some stuff we're talking about Rust. So first of all, the heap is going to be where most of your application's data is stored. That's where the main memory is allocated, and that's for everything in your program. So what Rust does, in most languages you have what's called garbage collection, and the program will routinely check to see what objects or variables or what have you are no longer being used, and it'll delete them from the heap to create more memory. Now in Rust, this is not done automatically. You need to specify that. So when we're doing things like referencing, if we take the original value that we're referencing and we destroy it, which we'll talk about in a sec, then the heap space that's allocated for that object is completely freed up. If you change an object, mutating it, things like that, you're going to create new space on the heap for that object and free up the old space. So it's going to change on the heap. And stack is just a series of pointers that point to the locations on the heap for your different objects. So a basic example, if you create a string is an object. So it has a value, but it also has a length. It also has like what kinds of byte representations each character are, what order they're in. Like there's a lot of attributes of a string, which is why it's represented by an object and not primitive. So when you have something like a string, you have a pointer in stack that will point to the heap that contains the area in the heap that contains the information about your string. The reason it's set up like this is because the stack is much faster to navigate. It's first in, last out, but it contains only pointers, so it's very, very quick to kind of like parse over, and then you just grab the pointer you need, and it points you to the object and all the attributes. That's what the application does at a very low level. Now, how that relates to borrowing? Well, as we said, each object and data type has its own location on the heap. So let's go ahead and flip back over to our example here. Now, when we're borrowing this value x, we're borrowing the original value set equal to x. What we're saying is, we're telling Rust, don't create a new space on the heap for this original value. And typically when you see this is when you're trying to reference a value from like a different scope, like if we had like a for loop going here, or even if we just created a block scope here, basically this is a new scope, and each time you pull an object into a new scope or a new function, or you do something to an object, like I said, you're gonna end up with new heap allocations and thus new pointers. The reference capability allows you to tell Rust, hey, don't do any of that. All we need is the value. So when we have like a string, like if we set original value to a string, and we set string from Dan, I don't know, some guy named Dan, and then basically what we're saying is all we need is this slice Dan. We don't care about the length of the string, we don't care about the byte values of the chars, we don't care about any of that. All we need is this particular value to conduct our business here. So Rust is gonna say, all right, sweet, like you don't need to actually go create all this new space. Sounds awesome. Now, this can be kind of tricky because you have to be careful about what you do with a variable that's referencing another variable's value. So let's take a look at what that kind of looks like. We already set original value to be mutable. So if we go ahead and say original value equals, we just change it to a new string, let's go with Josh. Now that's perfectly acceptable because we've already told Rust that this value is mutable, we can change it anytime we want, awesome. Now what if I try to do this? What if I try to print out x? Well, immediately we get a value error here. Cannot assign to original value because it is borrowed. So that's super important to remember. We originally declared this value to be the string, and whether or not it's mutable doesn't matter in the context of referencing. Like you're responsible for that. Rust isn't going to do the heavy lifting for you. It'll throw these errors and stuff, and if you've got a good plugin, you'll catch it before you run it. But like it's up to you to remember and to see these things and take care of the order of your references. So here we told x to point at the reference original value, and it was equal to Dan. Now right here, when we change that value, we have now freed up the original heap space that was representing the string of Dan, and we created a new heap space for the string of Josh. Now x is not pointing at just the value; it needs to go through that stack first to go to its location on the heap. So x is really pointing to the stack pointer. And since we went and changed our heap space, this pointer no longer points to a valid entry anymore. Like the pointer that we were referencing here has now been freed. So you can either have completely freed up space in the heap that this points to, or something totally different. So Rust is going to call you on that every time. It's going to say, hey, you are done with this value. Like you can't do this anymore. Now we can also try something like, all right, well, what if we just let x equal the reference again? Now that's cool, but that's because we're telling Rust, okay, reference it now after it's been changed, and now we're going to get that new pointer and it's going to direct us to the proper location on the heap. Now we talked about what happens if we change a value, and we quickly mentioned destroying a value. So what does destroying a value look like? Well, it just looks like this. We mentioned that there's scopes involved in these heap allocations. So if we just create this destroy function, and we have it taking a value that's going to be a string, and all we do is have it print out that string, that val, then technically what's happening is when we go and pass something from one function to another in here, we're moving it to a new scope, and that's going to change the heap allocation. So check it out. If I go down here and I say destroy, and I pipe in original value, nothing wrong with that right now. But if we try to go ahead and print x again after we pass that into destroy, you can't, because this value has moved out of scope. So the heap has changed, and we don't know what in this function that is going to be represented as, especially since we're not setting equal anything, we're not getting a return. Like this is called destroying a value. We're moving it out of scope, and Rust can't determine or guarantee that this reference is still going to be valid. It's still going to be the same as what we set up here. So pretty important to note. I know it's a lot to unpack, but as we go and as you see this and sign pop up more and as you use references a lot more and you can kind of read these errors and they're pretty helpful, you'll understand a lot more of like how to prioritize and how to like organize your references and make sure you don't get tripped up on this kind of stuff. And by the way, the ability for us to be able to check this kind of stuff, it comes at compile time, and it's called the borrow checker. That's what's going to generate these errors, and that's what's going to just take an initial look at all of your references and make sure that everything's in line. So you can leverage that borrow checker to really make sure that your code is solid. Now, we did references here, but we also briefly mentioned dereferencing. So what is dereferencing? Well, I'm quickly just going to add a note here and just say object is, quote, destroyed when it leaves scope. And now we're going to talk about dereferencing. So what is dereferencing? Well, as you can kind of imagine by its naming convention, it's sort of the opposite, like the reverse operation of referencing. So what this kind of looks like, the best way to kind of describe this, I guess, would be we're going to do two integer values. We're going to do let a equal 1, and then we're going to let b equal a reference to a. So we're just referencing that value like we did above. And now I'm going to just do an assert function. This is just a test in Rust. So we're going to assert that these values are going to be equal. So you can use this to do tests in your code. So I want to make sure that 1 is equal to x. And we are in a, I'm sorry. And we set this up here equal to a. So that should come back true. We just saw we didn't do anything to it. And now what about b? Well, that'll work. But if you just add this key right in front of it, just add an asterisk right in front of it, what we're actually going to check here is going to be the original value. So this is called a dereference. So what that, I'll add a comment here. This dereference b is equal to a. So that's a little bit tricky, I understand, and you're going to see this in some use cases in the future, so it'll make more sense in some of the future videos, like especially when we get into like iterating over vectors and over arrays. You're going to see how powerful this really is. But the gist of it is that when you dereference a value, you no longer are referencing A, you are now A. So we're going to assert 1 is equal to A, and we're also asserting 1 is equal to A here by dereferencing B and assuming A in its entirety. Cool, so that's a dereference, super awesome. And there's a couple things I want to mention quickly that are sort of related to this. The first is going to be what's called a static value. So a static value is kind of a neat feature in Rust, and what it basically means is it's a value that basically lives for the entire duration of your program. So you're basically telling Rust, like, hey, don't worry about tracking the lifetime of this value. We're going to set it equal to static, it's never going to expire. So up here when we're referencing stuff, whenever we go to destroy something, like that is the end of life of that value.
I think I understand this. So whenever you dereference, before you dereference, the value of B points to the same value, to the same heap location that A points to. So I think it goes to A and then gets the value associated with that pointer. But when you dereference, then it stops getting the value and just returns the actual pointer on the stack. I think that's what's happening. But seems like it's gonna be very difficult to keep that in mind and think about when. The tricky part is when to use those things is not really how they work, I think. And the same goes for everything else. I think that's the most challenging thing in the beginning.
Value. Anytime that the heap is changed or just freed up and not really reallocated, that is the end of an object's life. With a static, that life is perpetual. So to define static, we're going to just say let x, and we're going to let it be a string slice, and we're going to call it Dave. Now you haven't seen this before, and there's obviously a bunch of errors being thrown because Rust doesn't know that this is going to always be the same length. But when we incorporate a static call, like we talked about, suddenly this becomes okay. Because we're declaring this, it's going to be static, it's not going to change. This particular representation of x here isn't going to change. So let's see what that looks like. If we set y equal to a reference on x, and then we do that same destroy function, and we just do x to string. And now if we try to print out, like we did earlier, the value of y, which is referencing x, you see that suddenly we don't have this error anymore. Up here we get this error, but down here we don't. And that's because this is static. It's not being destroyed here. So I'm just going to say x is not destroyed here. So this can kind of complicate things. You got to be careful with statics because this can go into this function, and if you return it as something, you could possibly change the heap location. But typically what's going to happen is you'll just create a new location. Like this won't change. You have to do certain things to actually determine the end of life of a static value. But for the most part, this is what's kind of designed to do. I would use it at your own risk for now. It's something we're not going to cover in too much detail in this tutorial. Maybe in like more advanced topics in the future. But I just want to cover it real quick in case you see it in this playlist. Anyway, there's one more thing I want to cover since we're on the topic of memory, and that's going to be the usize data type, which we didn't cover yet. So I'm going to say function usize example here, and we're going to talk about what is a usize. Well, a usize is another way to declare an integer. But the interesting thing about usize is it's actually dependent on the architecture of your operating system. So we'll talk about that in a second. I'll just show you here. If we just let x be a usize type, and we set it equal to, like, let's say 2, you can see that's perfectly acceptable. It's a valid data type for an integer. And like I said, it depends on your OS architecture. So whether you've got like an x32 or an x64, basically what this data type is designed to do is it's designed to give you the guarantee that there's going to always be enough space in this representation to hold a pointer, like we talked about on the stack, for whichever size your pointer needs to be, whether it needs to be a certain size pointer for x32 or a certain size pointer for x64. That's basically the gist of it. And the number one spot you're going to see usizes is going to be in like indexes and in lengths and in stuff that's going to describe objects on a heap. The nice thing about usize, obviously, you can just use it as a declarative type, and it's irrelevant which operating system this program is actually being run on. So that's pretty neat. Figure since we're on the topic of memory, I would mention. Now, that's about as far into the rabbit hole that we're going to go on memory and on Rust's like garbage cleanup type rules. So hopefully this was enough to kind of give you a good overview and give you a good introduction to references and some of the rules around Rust memory allocation. This stuff's going to come up over time repeatedly as we do more examples, as we get into some example applications. So as with everything else that you're seeing for the first time in these videos, things will become clear as you see them in practice, as you see use cases and you can think about it logically. So appreciate you watching and check out the next video. Hello and welcome back to the Rust beginner tutorial on coding and crypto. So today we're going to be talking about some basic operations in Rust, mainly functions, conditionals, and loops. So you've already seen me work with functions quite a bit, and we've even touched on conditionals before, but we're just going to put it all in one place here, flesh out a little bit so you have it for reference. So the first thing we're going to cover is function returns. Now, this can be done in a couple of ways in Rust. So let's just do like function give me slice. We're going to tell it that the return type is going to be the static string slice value. And you can remember that from the last video that we did on borrowing and references and things like that. So we're just going to return pizza. So one thing that's super important to note is no matter how you do your return, whether with the keyword or any of the other methods that we're going to go over, you want to omit that semicolon. So super important detail right there. But so this is one way to do it. Whenever you have a return value, you have to declare the data type that this function is going to expect. So here's going to expect a string slice, and we're going to write another one that says give me string, and that one's going to, of course, expect a string. But now let's do this a little differently. We could do return string from pizza, or we could just simply omit this return statement. Since we don't have the semicolon here, we can just write this line like this, and that's our return. So it's kind of like a shorthand. And then you can even go so far as to do something like this, which is more of the same as what we just did, but in a very like strict down sense, this is totally acceptable too. So you don't even have to declare any kind of variable or anything. You can see we're just returning the number 4. So depending on your use case, that might be pretty convenient. So a lot of flexibility with returning values in functions. Now let's move on to conditionals here. So you guys definitely saw me do this already, but here's an official representation of conditionals in Rust. So if we just say let number equal 3, we could say if number is less than 5, print true. Now we're also going to say else if number equals 5, print, I don't know, like okay. And lastly, else meaning if it's less than, we're going to print false. And these are just arbitrary values. But that right there is conditional. So like I said, you've seen it before, but you know, they do make it pretty easy. It's very similar to, it looks similar to like a combination of like Java and Python, if I'm being honest, but not super verbose. Loops are even cooler actually. There's a lot of nice built-in functionality for loops in Rust. So let's take a look at, we'll start with a while loop. So a while loop is actually pretty simple to implement. One of the more simple ways to do a loop. You can just do the word loop, and then let's just do like print line again. And this is going to be an infinite loop. So just a little warning to the user here that this is an infinite loop. But yeah, this is a while loop right here. So obviously if you want to add logic to break out of this and stuff, or you want to have a counter or something, that's what you would probably do. But this will run forever unless you break out of it. How about a for loop? Well, a for loop is done a little bit differently. So you don't use the loop keyword for for loop. You still use for, like you probably seen in other languages. And let's just say for n in range 1 through 40. So that's a pretty neat thing right there. Rust lets you define a range just like that, inline, without having to call any kind of like function or embedded method or anything that will generate range for you. It's part of the structure of the language. So that part I think is super neat. And then we're just gonna do like, let's just do like hello, number, whatever, and we'll obviously just plug n into that. So cool. And the last type of loop that we're gonna cover is a loop that can actually store as a variable. So this is kind of cool. You can set a variable equal to a loop, and then whenever you break out of the loop with and return a value, that's what's gonna be set to that particular value. So that might be a mouthful, but let's just take a look at what that looks like in practice. So we start counter equals 0 to start. Then we're gonna let g equal the loop. And inside the loop, we're gonna just say if the counter equals 3, we're gonna break out of it. Now instead of going like this and just saying semicolon for break, I'm actually gonna go ahead and put these curly brackets here, and we're gonna return that donut slice. And then we can't forget to have semicolons in. But this is gonna obviously when this counter gets up to 3, it's gonna add this donut value as the value of g. So super cool. And this is you probably already think of use case for this is convenient, but don't do something like I just did. Make sure that you add some kind of incrementing function here. And then you actually have this counter going up. So you're good to go. So this was really good once over some basic operations in Rust. In the next video, we're gonna see collections and iterating. And so we're gonna look at things like vectors, which are similar to lists. And we're gonna look at arrays. We're gonna see how Rust offers different ways to iterate over these kind of like collection objects. So that was super helpful, and some of this stuff might tie in. So stay tuned. Thanks. Hey everybody, welcome back to the Rust beginner tutorial on coding and crypto. So today we're gonna be talking about collections. We're gonna talk about tuples, arrays, and vectors. We're gonna take a look at how you can iterate over those objects. So to start, let's start with the tuples. So tuples are pretty simple in Rust. You basically just use the parentheses to declare them. So we're gonna say let two, and this is how you tell what the types are supposed to be. Put a parenthesis. We're just gonna do two signed integers, 32 bits, and a string. We'll set that equals 1, 2, and string from all. Cool. So there's a tuple. So if we just did like print line here, oops, I'll show you how you can access those values in a tuple. So 2, and then to access the index of the tuple, you just do a dot. And you see they come up here in Visual Studio Code. So we'll just go ahead and print each of those, and these dang semicolons, and we'll just see what that looks like. Go into the basics folder here, and run cargo run. Oops, didn't save it. There you go. Now, what if we wanted to do a mutable tuple? Can we do that? Can we change just one value at a time? Well, yeah, sure. So let's go ahead and just make this mutable. And we're going to go ahead and just copy these down here because I'm going to print all the values again. But let's go with 2, and we'll change the string 1, so index 2, to a new string, and we'll just change it from Paul to John. So now if we take a look, there you go. So that's how you change the value of a tuple. That's how you do tuples in Rust. Super convenient. And now we're moving on to arrays. So I'm just going to minimize this a little bit. And if we want to take a look at arrays, they're also somewhat straightforward. There's a couple cool things you can do with arrays. Like you can use them to basically do different operations. And here's an example of a mutable one. So I32. Now when you declare an array, you want to do this bracket syntax here and declare the type that's going to be in the array. They all got the same type. And then you put a semicolon, and then you tell it what the length is going to be. So we're just going to do length of 3, and they're all going to be I32s. Awesome. Now to declare that, you just put the values in yourself. We're just going to do 4, 5, and 3. And I'll show you a couple ways that you can initialize an array without just like manually putting these variables or these values in. But either way, since it's mutable, to change a value in the array, you just reference the index like this and set it equal to your new value. So we're going to set both 0 and 1 equal to 0 and 1. Actually, I'm going to do 1 and 2, so the array comes out as 1, 2, 3. And then we're just going to do a quick loop over the array, referencing each value. And we're just going to print out each value as x. So we'll change this over to arrays. We'll get a cargo run going, and you see 1, 2, 3. Nice. Another way you can initialize an array is you can actually initialize with an expression. And this is pretty neat. I love this feature. So you can actually do, you can declare the array just like we did, right? So I32, we do like a 5 this time. But I don't really feel like typing out 5 whole values. What if I just want them all the same? If I want them all to be zeros and I want 5 of them? Well, all you have to do is put the brackets up like you did before, type the value you want in each field, and then how many? 5. There you go. So that'll give us an array size 5 of all zeros, and I'm just going to copy paste this because I'm lazy, and this will give us a printout of all those zeros. See? So 5 zeros. Nice. Now there's another cool feature with arrays. You can use them to initialize variables. So this is a little bit tricky, but follow along, and I'm sure you'll get it. So we're going to initialize an array, but we're not going to give it a name, right? Like there's no variable name here. We're going to put the variable names in an array itself. So I'm going to put 2 variables called drag and mark in this array structure. And I'm just going to put another array structure here, and we're just going to create some strings. So we'll do drag to string. Here's another way to create a string that we might not covered yet. And mark to string. It's just going to go from slice to an actual string object with that method. Nice. So now what this has done for us is initialize 2 variables using an array. And it's explicitly determined they're going to be strings. So we can actually print each of these out, but like how do we reference these? Like I said, we don't have a name for this array. Well, technically this array doesn't exist. It was just used here to build these variables, and now you can just access the variables as if they were normally initialized on a single line. See? And so we'll do each of that for drag and mark. We'll take a look at what that looks like. Boom. So kind of a neat feature with arrays. So now we're going to move on to vectors. So a vector in Rust is very similar to a list if you worked with a list before. It's just a collection of items, and they have a little bit more flexibility than arrays. Like an array is very size sensitive. In fact, whether it's immutable or not, you can't change the size without overwriting it. So with a vector, you can. You can append stuff to a vector, and it's designed to recreate its own length in the memory of the application. So pretty neat feature, and you can see in some of these examples we're going to write of that. Like, you'll see that flexibility compared to the array examples we just did. So to initialize a vector, this is how you declare the data type. We're going to stick with 532, and you can do it like this with the vec macro, and this is going to just let you type an array, and it'll convert it into a vector. You can also do, let's make a mutable one here. You can also do same data type declaration. You can use this range syntax, and then just do dot collect and make that into a vector with numbers 0 through 10 in each position. How cool is that? That is so cool. Anyways, we're going to copy this loop again. I'm lazy, and I'm going to come down and print out each value in the vector here. Whoops. And so we'll be able to see what that looks like here. Now, obviously, you know it's going to print 0 through 10, but we're going to see what that looks like. And now while we move on, I'm giving an example of appending to a vector. You just do vector.push -2. Now, one thing knows we made this thing mutable. So if you don't make it mutable, you're not going to be able to push new values to it. That's just straight mutability, obviously. But as long as it's mutable, you can change values, you can change the length of it, you know, you can do all kinds of things on there. And since we're pushing there, I'm going to print out the last value of the vector to see what we just pushed on there, right? So our last value right now is -1, and then we push -2 on there. So if we print this syntax here, we do vector, and then we reference the index. Now, if we know this thing for sure is going to be 11, we put 11 here. But the proper way to find the last index of a vector is to just do the length, vector.len, -1. And that should give us a nice printout of the last value. So I'm going to just comment this out while I run this so you don't get confused, but there goes -2. I always forget to save it. Either way, we got that -2 out there, so we know that's our last value. So what we're going to do now is we're going to demonstrate pop as well. So we're going to do same print, and we're going to do vector.pop. And what pop does is actually removes the value from the vector. It'll plug it out or pop it out and return it. Now, right now, Rust is yelling at us because the pop function actually returns an option. So what an option means, and we're going to talk about this in a couple videos from now, it basically means that you can either get a value back or you can get none. And in order to handle that operation, you're supposed to write like the handling, basically how you want to handle the 2 possible outcomes of an option. But for simplicity here, since we're not going to dive into this yet, this is a print filter you can add that will automatically recognize that this is a return option. So all you have to think right now is this pop function could return value, but if our vector is empty, like if you pop, if you use a loop to pop all of them out, you're going to get none. So I'll demonstrate what that looks like, and then I can show you. See, like sum -2. Sum is the option return of a valid value. So if we go like this and we say loop, actually it's probably good. I won't do it. Never mind. I'll do it for x in 0 to 20. So you can see some of the none printouts. So this is going to pop every single value. And as we get past 11, since we're going to have 11 values or 10, this is going to pop us up into the none return value. So you'll see that. See, we get some value each time, and then once our vector is empty, we get none. Cool, nice. So we're going to move on now to, I'm just going to set this back to this so that nobody gets confused. We're going to code on GitHub. We're going to move on to iterating. So iterating. So iterating is pretty neat. Like you just saw the for loop is one way to iterate. That's a pretty traditional way to do it. But there's more robust ways to iterate over these different data types in Rust. So let's take a look at iterating over arrays. So we'll start with just a typical array. We'll just say let r go with 32 again, 5, and we'll do this all zeros because it's cool. Now, the first way we can iterate over something in Rust is using the built-in function for arrays called .iter. So if we do for x and r.iter, and we just want to print x, we can do that. Now, a couple important things. So obviously, at a basic level, x is going to iterate over the array, and we're going to get each value of the array. But what's important to note is .iter is actually built-in referencing the array. So this is going to be by reference, and I'm just going to do .iter in parentheses. Now take a look. If I try to actually reference the array, it's going to geek out because this is already referencing it. So you don't need to put the & sign in front of that. Sweet. Okay. So now let's take a look at what's called enumeration. So we're going to do the same thing, but we're going to enumerate this. Now already you can see that this is not throwing error, and that's because enumerate, let's see what Rust is saying. See, it's giving us this tuple here. That's saying that's what x represents. So enumerate is going to actually give you the tuple representation, gives you a tuple, and it's going to look like this. It's going to be the index of the array and then the value. So super important to know, this is extremely convenient because use cases for this come up all the time. We need the index and the value. This is how you do it. Again, since we're using .iter, we're still going to be referencing that value. So again, like we saw in the tuples above, all we got to do to get the value is just reference that tuple index. Sweet. So now we'll just give this a print and just take a look at what that looks like. So there's our zeros, and obviously we're just printing the values here. But if we want to do like x.0, we want to comment this out, you can see those indexes. So pretty neat. Now these two examples that we just went over are by reference. So is there a built-in iteration method for taking the value itself and not just borrowing? Absolutely. So we're going to do by value, and it's actually called into iter. So kind of confusing. It's very, very similar, .iter versus .int iter. But if you can just remember that the .iter is going to be referencing it, and then if you go into iter, you're pulling the value in, so you're not borrowing. So one way to kind of think about it. So we'll do for x in r. And actually, I'm going to make this item because we're going to mess with that enumeration a little bit. And we're going to say into iter, enumerate. And then as you saw, it's going to be a tuple. Now you can choose to do both index and value of the tuple. So that looks like this. You can say let I and x, and this time we're using tuples and array to create these values. Same concept though, still pretty cool. Because we want to have two different types, so that's why we use tuple here instead of like we saw here. We're using array to create two values because these we know are going to be the same. They both can be strings. But down here when we use tuple, we can tell Rust like, hey, one of these, the first one's going to be a usize, and the next one's going to be an I32. So we're going to set equal item. And really quickly, usize is a representation of length. It's a representation of index. It's used to determine a number that actually represents stuff that's coordinated on the stack in the heap. So if you watch the borrowing video earlier in the playlist, you kind of understand what this points to. I did reference it in that video as well. So now that we've done that, we can just print out. Let's just do like we'll say index. Oops. And we'll say we'll make those brackets there, and then we'll do value brackets, and we'll just do I and x. Now we could have totally done this like we did earlier, but it's a little more clean to do this. And obviously in the typical use case, you'd be doing more than just printing these things out, so it's good to toss in their own variable for the scope of the for loop. So totally cool. Let's take a look at how that works. Right on. Sweet. So that's arrays, and iterating over vectors is actually very similar. So they iterate the same as arrays. And there's a couple like cool features about vectors that we'll cover too, but just to show you, we're just gonna let the vector equal I32, and since I love this range collect guy, we're gonna do that. And now for x in vector.iter, we're just gonna print line x. So you can see it's exactly the same as the array one. Literally the same. Sweet. And all these are the same too. And if we return the same tuple, it works the same exact way. So what's different about vectors then? And I'm just gonna do a quick print line here and sort of separate the vectors from the arrays. So what's neat about vectors is you can also do stuff to a mutable vector. Like we covered earlier how you do different things like pushing and popping to a mutable vector. But when you iterate over a mutable vector, you can actually do stuff to it while you're iterating. And that looks like this. We're gonna create a mutable vector called mute vector. Use I32 again. And you know I'm gonna use this range function again. And now that we've got that declared, we're gonna do for x in mute vector dot iter mute. So iter mute actually is going to iterate over a mutable vector and allow you to do things to the vector. So this is what that looks like. Asterisk x, and we're just gonna add 3 to each value. Now what this asterisk is actually doing is called dereferencing. So if you watch the video on borrowing earlier in this playlist, you know exactly what that means. But in a nutshell, this asterisk tells Rust like, okay, even though x is just like serving as a representation of this value, since we're iterating with this mutability feature, we're gonna dereference from x to the actual value in the vector. Like actually do this function on that thing inside that vector that we're iterating over. So that's all that means. Now we can print this out, and you're gonna see the same like syntax we saw earlier when we printed a whole vector. We print like vector pop. We're gonna use the same option filter here with the question mark because when you print a mutable vector, Rust doesn't really know what size it's gonna be. Like you can't predict it ahead of time. So it could be 0, it could have nothing in it, and you're not gonna be able to print anything. So this also returns an option like we covered earlier, and I promise that will become clear in a later video. But for now, let's just print this out and let's see what we get. Sweet. So you can see we print out our original vector 0 through 4, and now each of the values in here are actually increased by 3 because we went added.
Oh,
So pretty neat.
I got it. I think I mistake. I misunderstood the reference thing. I think it's the other way around. When you dereference, you actually point it to the value, and when you don't, you point to the pointer of the value.
Iter mute is a pretty powerful function. Allows you to just kind of simplify things by dereferencing. Super, super cool. In the next video, we're gonna talk about options and matching, so you're gonna see a little bit more fleshed out details on some of the things we glossed over in this video. So that'll be super helpful. Thank you for watching.
There's a lot of things to remember though.
Hello and welcome back to the Rust Beginners tutorial on coding crypto. So today we're going to be diving into options and also matching. So these are both honestly some of the coolest parts about Rust, and I'll explain why. So the biggest concept here is Rust does not have null. So there's no such thing as null in the entire language of Rust. There's what's called none, and there's a big difference. So Rust will actually force you to handle the possibility of a null value. If you watch the previous video on collections, you saw when we tried to pop a vector, there was errors being thrown because we had a possibility of there being no values to pop. Therefore,
Also, the other thing that I'm thinking about and I don't understand really well is that the exclamation mark seems to be something that is used to activate a macro, and a macro is probably a script or something like that that you can that comes from standard library or you can create probably. But then how do you do negative values if the exclamation is already being used for something else?
Rust is telling us we need to implement an option. So, like I said, instead, we use options. Now, this is what an option looks like, but these come as part of the Rust language, so you don't have to actually define this. I'm just doing this demonstration. So, and this is also kind of a good concept to grasp.
Not negative values, but negative conditions. Like in other languages, you can put exclamation mark and then true or false, and it's gonna give you the opposite. So I wonder how that's done on Rust.
This T here represents a generic, and that's outside the scope of this tutorial here, but in essence, think of this as like x as a function. So you have an option of whatever you're gonna pass in. It could be this value, or it could be none, right? In the case of our vector, this would have been our vector pop. Anyway, this is what an option looks like. It's either some or none. So if you want to implement it, let's do a little option example here. It looks just like this. So we're gonna go back to our already previously seen vector conundrum, and now that we've got this initialized here, we're just gonna create a loop for I in 0, 5 range, and we're just going to try to do that same thing again, right? We're gonna just try to print, and we're gonna try to pipe in vector pop. Oops. And you can see that we're gonna see the same error we saw before, but we didn't really read this last time. So what's actually happening is this value that we're trying to pipe into the string for now is actually an option. It's not whatever's in our vectors. Like here, our vector is a bunch of integers. This is an option. It's either gonna be some integer or none, like we talked about. That's why when you saw it print out, it looked like this. It looked like some. It looked like none. That's because we put this option filter on the print statement, and that just prints the actual option itself, like the enum, which we'll cover. But the correct way to actually do this is to handle that possibility of a none, to handle that option that you're going to get back from this function. So what does that look like? How do we get rid of this? Well, how do we get our actual value really is the question. So what we want to do is we want to go like this. We're going to say let x equal, and so originally we want it to be equal to vector pot, right? Instead what we're going to do is we're going to say match. Now this is the match keyword, and this allows you to match possibilities within a value. So it's very similar to a conditional, or if you're familiar with the switch case, but these are really slick, honestly. So check this out. We're going to match vector pot. And since it's an option, it has multiple possibilities. Like we know this up here is an option. It's an enum. We're going to do sum, and we're going to set a lambda expression. So you can just use whatever kind of representation you want for the value. Let's just use like val. And if it is some value, like something is existent from, like something's returned from this, then just give us that. Give us that value. If it's none, give us a 0. Close that out. And then within our for loop, we're going to just do print line. And now you'll see we can just use x. Sweet. So like I said, this is part of Rust's internal library, so you don't need to actually find this. I'll just comment that out so you can see that. And then we're going to run this bad boy. We open a new terminal. We're going to slide into our project. And do cargo run. See, we get 3, 2, 1. And now all our values have been popped out after 1, so we get the 0 back. Sweet. Awesome. So that's literally options. This is what Rust wants you to do to handle whatever it is that might throw a none. And these are pretty expensive. Like you can create whole expressions in here and a bunch of different methods and what have you. So definitely explore that a little bit. Now let's take a closer look at this match function, because this thing is super nice. So let's create a new function called match this, and we're going to actually pass in a variable called val, and it's going to be i32. And let's just expect a string to come back. Now all we need to do, all we need to return is the result of a match statement. So again, we're going to use the match keyword. We're going to match val, and we're going to say, okay, we know we're getting i32, right? So what we want to do is say, all right, 1, give us the string 1. And then I'm just going to add this clipboard here. If it's 2, give us the string 2. If it's 3, 3. And then the last most important piece of a match is you have to handle if it doesn't. Like if you're using something like this where you're not matching a predefined set or predefined enum, you're kind of creating your own terms. You have to have a use case for if there's nothing there, it doesn't match any of the things on this list. And that looks like that. So in a lot of languages, this is referred to as like default or something like that. This is what it looks like in Rust. And we're just going to put down this. It's not on our list of values. Cool. Let's test that out. I'm going to do a little function match example here, keep things separated. And we're going to print line, good old print line, match this. I'm going to do 1, and I'll go and do each of those values. And then we're going to try 4, which is obviously going to be outside the scope. So we're trying to get this. And then we'll just toss this down here and run it. Nice. We got 1, 2, and 3 in text like we wrote it. And then for 4 that was outside the list, we got back that not listed. So that's how match works. And like I said, slick, this thing is super useful. There's not a lot of code to write conditionals and things like that. So you can easily see like how nice this really would be. So definitely use this. And it comes in really handy working with enums, which we're going to cover next. Hello and welcome back to the Rust beginner tutorial on coding in crypto. And here we're going to be talking about structs. So structs are a way in Rust to represent an object. So they're very similar to classes. You can define attributes of a struct. You can define methods, which are just like functions that are part of that object. And there's a lot that you can do with these kind of data types. So obviously super important for any kind of object-oriented programming. So the way that you define a struct is you just use the struct keyword. And we're going to just call this one user.
So he's saying it still works on as in other languages. So it's still the same thing. The exclamation point.
And we're going to add some attributes. So when you add an attribute, you're going to have to provide the data type. So we're going to go with username, email. Those are both going to be strings. Then I guess we'll just count like the number of times somebody signed in. And we'll determine if they are active with a Boolean. Cool. So that right there is how you define a struct. Now, if you want to use it, you have to initialize it. And you have to actually initialize it into some kind of variable or, as part of an operation or what have you. So we're just going to initialize it as a variable. So we're going to say let user1 equal user, curly braces. And now we're going to determine each of those attributes. So let's set the email to, I don't know, like someone at example.com. We'll set the username to some username, 1, 2, 3. And as you can see, it doesn't matter the order, right? Like we started with username and then we went to email. Like you don't have to determine the order or follow that order. You can just, since you're using the keywords of the attributes, it doesn't really matter. Active, we're going to say true. And how many times did they sign in? I don't know, once. And now this user1 is of type user, and it's going to have all these attributes that we presented here. Cool, nice. One neat function with structs is if you wanted to initialize it, let's just say initialize struct simple. If you wanted to initialize it and your function actually is using the same like keywords, the same variable names, you don't have to actually declare the attribute name. So I'll show you exactly what that means. If we explicitly say that we're going to get username and email as strings in our function, and then we want to go in and say let user1 equal user. Originally, what you saw was we did email, and it would look like this, right? Like we would have username, and it honestly just looks kind of silly. So what you could really do is you could just do something like this. We'll just comment that out so you can see it still. All you have to do is just declare that you're passing those in. And because they have the same name, you don't have to worry about this like declarative kind of representation. Rust knows. It knows that it's called username, and it implicitly is going to know to put it on either the username or the email attribute based on the name. So super cool. And then the other ones we don't have part of our like function header, so we're just going to pass those in normal. But that's pretty interesting. So, like I said, when params have the same name, you can just pass them. Add that comment for you guys on GitHub. Now, that's how you initialize a struct. So what about like updating the values in a struct? Well, let's cover that then. So let's go with a function update struct. And I'm just going to copy this up here again. So we're going to make user1 equal to this again. And what you can actually do is if you wanted to update something, we have to first make this mutable. And then you're going to want to say user1 dot email, and let's change it to string from someone new at example.com. So that's how you go ahead and change an attribute of an existing object that's represented by a struct. Now, you can also do something pretty neat, which is related. You can actually inherit the rest of the values from one user. And what does that really mean? Well, it's probably easiest to just write the code and then talk about it. So if we want user2 to be of the struct user, to be an object of type user, instead of typing in all of the attributes, if we want to inherit, let's say we want to inherit both of these values from user1, like we want to just like copy it. Instead of trying to set user2 equal to user1 and having to use references and things like that, what you can do is, we're going to copy these over, but what you can do is let's say this is going to be some just different names here to represent. Let's take these out, and actually we can do .user1. And that's just going to say, okay, we declared these two attributes to be these, but then everything else that's part of this struct that is required to initialize, just copy it from user1. So that's pretty nice. Comes in handy, and you could definitely think of some use cases there. So what about methods? If you guys are familiar with classes, you obviously know about methods. So let's talk about how those...
So it's same thing with JavaScript, where you can have this operator to copy or clone the other arrays.
I'm going to use the rest of this page here for this, so I'm going to space this out a little bit. But let's introduce a new struct. We're going to do person. And the person is going to just have a first name of string and a last name of string. So in order to implement a method for this person struct, traditionally what you'd see in a lot of languages is like these sort of curly braces are going to represent the scope. And inside you would type like a function like, let's say, hello. But Rust is immediately going to say, you can't do that. So functions are not allowed in struct definitions. Instead, what you have to do is define them separately using this impl keyword, which is implement. So we're going to implement person, and we're going to define these methods down here. So this part's going to be really important. First, we're going to show what Rust recognizes as a method, and it's going to use this reference to itself. So if we just do like details, you have to pass @self in as a parameter. You can pass other parameters, but that one is required. If you're familiar with Python, this is also very similar to how Python works for methods. And let's just go with like a string from, and we're going to actually reference one of the attributes of the struct itself. So self again, and we'll do last name. Cool, so you can see that the IDE doesn't recognize any errors with that. So this is a method. Now, let's go ahead.
I kind of understand, I'm not sure if that's correct, but I think struct is kind of like a class. Is the attributes of a class, and then implement is the functions of the class. So at least that's the way that makes sense to me the most now. Because it's, yeah.
Go ahead and create an example down here so we can see exactly what the importance of a method versus what's called an associated function, which we'll get to in a sec. So let's just create this example function. Whoops. And I'm going to say let George equal person. And his first name is going to be string from George, obviously. And his last name is going to be string from Lopez. So we got George Lopez here. Now, we can do this function here and just print out the result of our details method and get George's name, right? Like we told it to return the last name. So this is going to print out Lopez. But what if we instead, let's say we write a new function up here and we want to say, I don't know, let's do like function more details. And we'll do the same thing. We'll just have it return a string. And let's say this time we're going to do George's, well, the struct's first name. Now, right off the bat, we're getting an error. Rust says self is a keyword only available in methods with a self parameter. So we didn't pass that self reference in as a parameter. Therefore, this is not recognized as a method. This is instead recognized as what's called an associated function. And obviously, the difference being is that it does not use the self reference. So what is an associated function?
So I think it's like a static method in Python, where you have a function that is just part of the class, but it doesn't reference to the class.
Well, an associated function, if you've ever programmed in Java, it's similar to a static method. Basically, it's an attribute of the module itself. It has nothing to do with the attribute values of the struct that you created. It's instead just a function.
Now I think I finally got it, what a struct is and the implements. This explanation, I think, made it. Maybe it's because I just watched it before, but I'm not sure also if I'm making the right connection, but it seems like it's the same thing. It's just a different way to implement a class, and you split on two different things. But also, there's probably use cases where you just use the struct as well, so not sure.
That is included in this structure. So like it helps really for like code organization and things like that. Like if you have the person object, and then there's some methods that you can do different operations on the attributes. You might also have some functions that are just related to like a person object that you might want to just store in that particular Rust file, whatever you want to do. But to get rid of this error, we have to return something that doesn't have anything to do with the attributes. So I'm going to go back to my classic pizza example. And going off of what we just talked about.
The biggest thing that I'm trying to understand while watching these videos is not necessarily even what the syntax is or how it is. It's more about, and this is something that I had difficulty with, and I think it's normal with the other languages. It's not about how you write the code, it's when to use each thing. That's where it gets hard, I think. So when should you implement class, and then you get into different paradigms like functional programming or object-oriented programming and software design. I think those things are more important and difficult to understand. So that's the kind of the thing that I'm trying to get a sense of, because when I actually start writing the code, I can figure out the syntax pretty easily just by searching, but to understand when I should do certain things or not, I think it's going to be very hard.
Obviously, can't implement this in the same way that we did above. Namely, we can't.
And also, obviously, all the memory stuff, because I'm not used to doing that. The references and pointers, which is also something that I think I'm going to struggle with, understanding when to use those things.
This representation, and then do George.more details. Grab my semicolon here. Because, like we said, this is an associated function, not a method. And Rust is telling us the same thing. this has nothing to do with George. Like we just created George as a person, and George is an object. But since this is an associated function that doesn't relate to the attributes, more commonly known as a static method in other languages, instead it's an attribute of the struct itself. So we're going to just do person, and here we have a syntax change. So now our error goes away, and this is super important to note. Double colons and the name of the struct for associated methods or associated functions, and then the name of the object you created with the struct, and a period or dot to represent a method. So pretty interesting. That's really the gist of structs. And these are going to come in extremely handy, obviously, with object-oriented programming and with things like data type handling and maybe like REST API. So
I don't think I
what
understood the last part here.
is an associated function? Well, an associated function, if you've ever programmed in Java, it's similar to a static method. Basically, it's an attribute of the module itself. It has nothing to do with the attribute values of the struct that you created. It's instead just a function that is included in this structure. So like it helps really for like code organization and things like that. Like if you have the person object and then there's some methods that you can do different operations on the attributes, you might also have some functions that are just related to like a person object that you might want to just store in that particular Rust file, whatever you want to do. But to get rid of this error, we have to return something that doesn't have anything to do with the attributes. So I'm going to go back to my classic pizza example. And going off of what we just talked about, we obviously can't implement this in the same way that we did above. Namely, we can't just type this representation and then do George.more details. Grab my semicolon here. Because
I guess it doesn't matter the way you call it. I was thinking about how it's gonna be referenced to the George instance of the class or the implementation. But I guess it doesn't matter because it's a static method, so either way it's not related to the instance itself, but I'm not sure.
we said, this is an associated function, not a method. And Rust is telling us the same thing. This has nothing to do with George. Like we just created George as a person, and George is an object. But since this is an associated function that doesn't relate to the attributes, more commonly known as a static method in other languages, instead it's an attribute of the struct itself. So we're going to just do person, and here we have a syntax change. So now our error goes away, and this is super important to note. Double colons and the name of the struct for associated methods or associated functions, and then the name of the object you created with the struct, and a period or dot to represent a method. So pretty interesting. That's really the gist of structs. And these are going to come in extremely handy, obviously, with object-oriented programming and with things like data type handling and maybe like REST API response bodies and stuff like that. There's going to be some really cool features you can do with structs. Hey guys, welcome back to the Rust beginner tutorial on coding and crypto. And today we're going to talk about enums. So you got a little taste of enums in the last video, right? We talked about options, and we said that options and match were some of the coolest parts about Rust. And options are an enum. So what does that make enums? Enums are super, super powerful. And a big part of Rust actually relies on enums. So we're going to go into some detail here on how you use them, and we'll also give like a high-level overview of exactly what they're doing in a memory sense. So first, to define an enum, like you saw, we're going to create this stoplight enum. And we're going to have green, yellow, and red. And now, we talked about the match function, or the match keyword, in that last video. And you saw with options how you can match. And like I said, you don't have to handle like a wildcard case or like a not match case, because enums have a definite list here. There's only these amount of values it could be. So if your function is expecting an enum, like if we write read light, and we say that we're going to get this variable light, and it's going to be of type stoplight, which is an enum, then your match case knows like, okay, there's no way that if we get an enum, it's going to ever be anything besides these, because that's not possible. Rust wouldn't let it get that far. So what we're going to do is
Maybe
we're
I
going to
should write this stuff down actually, because it's gonna help me remember if I write it down. Struct. Just do this color to make it easier.
match this entry, this light value, to whatever kind of type of enum that we get and return some kind of value. So let's just return string. And then we're going to say, all right, match light. And now we want to take a look at the possibilities that this could be any of those values. So what we want to say is, If it's stoplight green, then we're going to say go. Just string. And I think you can guess what we're going to do here, but if it's yellow, we're going to do slow down. And if it's red, yep, you guessed it, stop. So pretty cool. Now that's all you have to do. And like I said, because Rust knows that it can only be any of these values, you've already bound it to the possibilities that are represented by this enum. That's an integral part of memory management and of handling like nulls. Like there's no null in this situation. Like this function can't see a null. So pretty neat. But anyways, right, let's print this out. Let's go with the, I like to keep all these functions separate so I can just copy it onto GitHub for you guys. But let's do our readLight function. And see, it's already telling us like, hey, make sure you put in this enum here. We're going to do stoplight green. And of course, we're going to print out each of those and run this guy. And we'll see what that does. Slide into our guy again here. And see, we get each of those things. So that's how you can use an enum and a match to kind of like dictate different things about your program. And again, this is another thing that you can expand on. Like you can make these be full functions and expressions in there, not just like return.
So maybe, and this I'm not really sure about, but I think enum plus match works like an object in other languages. Enum is the properties, is the keys, a match places the values. So this is what makes sense to me right now, but I could be wrong about this. This other one I feel more confident about, but yeah.
Return values. So there's a lot you can do there. But enums can actually get a lot more advanced than this. This is what's called a unit type enum. And at a high level, what that means is basically this like English word, like this human readable word, doesn't mean anything to the compiler. It's just so you can represent it with your code. But there's an underlying value behind these that points to different parts of the memory of the app. And without going into like excruciating detail, these are just like representers. And they enable you to write stuff like this in a nice, simple way. Now, what we're going to look at is a different type of enum where you actually have things like functions present in the enum. You have like structs that can be in these places here. And then it works with the memory a little bit differently. So we're going to take a look at how these are written. We won't dive too much into the memory stuff. I'm not trying to slam you guys in a beginner tutorial, but we're definitely going to see these things in practice. So let's go ahead and create some space here and talk about advanced enums. And this one's we're gonna have a little fun with this. We're gonna do a golf event enum. So the first event we're gonna allow is a tee up. And like we said before, this is a unit. And it's gonna represent the golfer is teeing up the ball. So there's really no like values or anything involved. It's just something that's happening. The next type of event we're gonna have is the golfer's drive. And I'm gonna keep all of these data types as strings because it's kind of a pain to get them into like a printable statement. I don't really want to get into all that messy stuff. I want to really just demonstrate the enum. So you're gonna see strings here, but you could do integers and stuff too. So if we're gonna drive here, that string, we're gonna have this function really. And it's gonna allow us to basically build.
So it's not really like an object. I guess it's different. But it kind of works the same way, yeah, the way that he explained there. But I guess it's different. It allows you to do more stuff. Yeah, I'm gonna have to think about a good way to associate this with things I already know from other languages, so it's easier to understand the concept and what's the point of having this. Enum so far is the hardest one for me to understand, I think, from all the languages. Even I think Solidity uses enum as well, but I don't understand really well when to use it.
Build functions on the enum and pass strings into them. And we're gonna be able to say the golfer drives the ball and yards. And then our last enum option that we're gonna have is a club select. And this one's gonna be a struct. So we're gonna just do an inline struct here, where we're gonna have a club as a string, and we're gonna have the max yardage that dude hits on that club as another string. Cool. And we'll just define that real quick. Struct. The golfer selects a new club. So this looks pretty wacky. And you're probably wondering, okay, what does any of this even really mean? Well, let's see it implemented with a match, and you can kind of get a better glimpse of what's going on here. So if we just do like, let's do golf event as a function name. And let's say we want to pass into this function, just like we did up here with the light. We want to pass into here a golf event. And we want to get back a string, just like we did before. Same kind of a setup here. So match event, like earlier. And we're going to define what's going to happen for each of these golf events. Now, I'm going to copy these in real quick so you guys don't have to watch all this. Now, don't worry about initializing these ones just yet. We'll get down there. Let's start with the tee up. So there's no values or anything involved. It's just a unit type, just like we saw up here with the light. So we're just going to return some kind of like generic string message. Like we're going to say the golfer is teeing up the ball. And of course, we'll do that to string guy. And now for the drive, this is where things get kind of interesting. So we're going to write a little expression here that's going to say, all right, we're going to input the amount of yards as a string. And our string that comes out is going to look like this. And you can see what we're kind of doing. We're just kind of creating a nice concatenated string here. Oh, forgot space right here. So cool. Now we're going to actually build a function based on this right here. We can pass in this value yards, and we can get what's going to be printed out here for the yards. So we're going to do something very, very similar with the struct as well. So let's see how we initialize this guy. So we're going to...
Oh, so you're talking about him, the way he did it, and not my description? calling that is totally bad, wrong, calling that enum type as a function. He's the first one I've seen saying that. In Rust it's called a tuple variant. Tuple variant. And what's the difference between a tuple variant? Maybe I'm gonna write this down and then I'll search later. And do you think this description here makes sense, or I should scratch this? And how would you associate enum with a language that like Python or JavaScript that doesn't have anything like that? Or is impossible to associate it because they don't really work the same way? Yeah, I don't think this description is very accurate, but it gives me a better idea of how it works. But there's probably a better way to write it down. It's more the naming than the function, but calling it function will probably just confuse some when they look at other videos that call them tuple variants. Oh, okay. Got it. Yeah, and this part here is also a little bit confusing and difficult to understand because now he's merging the two concepts. So this is the enum, and then you have a struct here inside. But inside of here, it looks like an object, but it's just a description of the types here. So guys, I get it. But on the first struct, he didn't specify the types. He just put arbitrary stuff there. And then he talked about that the compiler doesn't know what each thing is. It's just a reference in memory. So what's the difference there? Why here you have to specify and there you don't?
We're going to do club.
It's kind of confusing.
And just like we have above, max yard. And we're going to say golfer has equipped. Copy this again. And this is, again, going to be kind of messy, but I'll try to get through it quick. And so he's equipped a club. And the max yardage he's hit with that club is going to be that max yard value. Nice. All right, nice. So there's obviously more complicated things you can do with a struct in this situation. This is a very simple example. But ideally, you would have an object with attributes and stuff like that that you'd be able to do things with in here. So kind of cool. But all right, so let's see this in action then. We're going to write another example. And we're going to say match golf example. And this is where we're just going to like print all these. So just like above, I'll actually copy them, try to save you guys from that a little bit. So instead of this, obviously, we're going to do golf event. See, telling us again that we need to have a golf event. And copy these all in here. The first one we're going to do is, of course, the tee up. So golf event, tee up.
Oh, another thing that I just thought about is that maybe he's talking like that because it's for for beginners. So usually beginners are probably going to be people that come from other languages. So and then more likely they understand what a function is, but they might not understand what a tuple variant is.
So what we're going to do is a golf event, and we're going to
But
do
I'm not
drive,
sure,
and right
obviously.
here is where we're going to tell
Not the
our
guy,
function that we defined
so.
up here just how many yards this person's going to hit. Let's go with like 250. Sweet. Now, and we're going to have to obviously put this to string. Trust me, it could be worse. This is already messy, but it could definitely be more messy, trying to go from numbers and stuff. But anyway, so we're going to obviously see what that's going to give us to print out. Now, same thing goes for the struct one. We want to just create that club select struct, and we're going to go ahead and pass in the value for club. We'll go with 6 iron. And, oh, that's 2 string. And then we're also going to do max yard. It's going to be 175 with the 6 iron. That seems reasonable. Cool. All right. And now we're just going to print that example out here, like we've done before. And there you go. We get our 250 that we piped in here, and we get both of the values that we put in to the struct. So kind of neat. That's how you can use enums. Like basically what we have right here is we have a function, a match function, that is built on an enum. And now we can just pass enums into that match function, and we never have to worry about null. So that's like the biggest lesson. I'm going to quickly talk about one other aspect of enums that's kind of sweet. Enums also have methods, just like structs. So let's just quickly do like a basic enum that you can probably see just about anywhere. We're going to do forward and backward. And then, like we saw with the structs, to define methods or associated functions, you use this impl keyword. Same thing with enums. So we're going to just add a nice little walk function here. This is going to be a method. And we're just going to print out like walking. And then we're also going to do, and I'll label this, we're going to do an associated function.
So this I'm going to write down because I'm definitely going to search for this later. I'm going to have to watch a bunch of different videos to understand this better, so I think I should write it down. Because it seems that they're very similar from what the description here.
And if you remember from that previous video on structs, what the difference is, one of them is obviously referencing the self, the object itself. The other one is not. Now, I'm not going to go into like how you use attributes and stuff with enums. It's a little bit complicated, like how you can make this actually referencing something of its own. It's a little bit tricky, but eventually we're going to have a brand new tutorial coming out that you'll be able to check stuff like that out, a little bit more advanced topics. All right, so now that we've got that set up here, let's just go ahead and create another example. And we'll just do like methods example. And we're just going to demonstrate what each of those methods do. So if we let direction equal direction, and we'll go forward. Nobody wants to run backward. And we're just going to do print line. And we're going to utilize that option filter there. Direction.walk. Now, if you remember from the previous situation where we tried to have this, be the same kind of thing with an associated function, like if we did run here, we're not allowed to do that. Instead, this is an attribute of the enum, not the object created by the enum or with the enum. Cool. And obviously, we're just going to do this as a print, and we'll see that in action. See? So that's pretty cool. Enums are definitely pretty cool, and if you can really get good at these, you're going to have an easy time programming in Rust because you'll avoid a lot of headache with unexpected values and things like that. Thanks for watching. Hey everybody, welcome back to the Rust beginner tutorial on coding and crypto. So if you made it this far, we've covered a lot of really great basic topics. And now we're going to actually build something. We're going to build a sample application, much more robust than the first one we did. That's going to encompass a lot of that stuff that we've seen in this tutorial.
I think
so
this,
what are we going
this
to build?
was the
Well, it looks
first
like
video
this.
I saw from
We're going to build a little blockchain querying app. So we're going to look up information from the Bitcoin blockchain, and we're going to do stuff with it and come up with some, conclusions in our Rust application. So you can see here from this diagram, this is what our app's going to do. We're going to figure out what chain we're using from the Bitcoin blockchain. So is it the mainnet, is it testnet, like whatever. Then we're going to look up some information about a particular wallet address, and that's going to give us all the transaction hashes that wallet's done. So we'll look up each of those transaction hashes, and finally we'll use all that information to calculate that wallet's current balance. So it'll be super cool. You're basically going to be doing a parsing of the blockchain to find out how much Bitcoin your wallet has. And
which is exactly what I want to do, but not in Bitcoin, in Ethereum first, and then the other chains.
The same address every transaction, then this thing's extremely accurate. It's all on the network, so it's going to give you that return value. So pretty cool. What you're going to need to do this is obviously you're going to need a Bitcoin wallet address to look up, to plug into this thing, to get some information about. So you can create one, you can use one of your own, and we're going to actually protect the wallet address and API key.
Struct must have all its fields initialized. Enum can only have one variant active. So you mean one variant of the whole enum, or one variant inside of the enum? I guess it makes more sense for the... actually, I don't know. What do you mean by active? Let's have all its fields initialized. So there's something on TypeScript that... let's see if I remember how to do this. Okay. That is... I'm not sure if it's enums or struct, but that you put a value like this, and then you put the question mark, and then you make it option. I think is enum. Yeah, something like that. Does Rust have the same thing, or... First option is set. Okay. So you can only have one active at a time, one enum. But what do you mean by active as well? So I can only reference to it at one time? What if I want two enums that have exactly the same properties? Wouldn't I be repeating myself a lot if I have to code every time the same thing? It's gonna take me some time as well to understand. There's no point in... I think usually what I do is just watch a bunch of videos over and over and over again until it finally clicks. So I think that's... Yeah, probably that's the best strategy. So first the beginner stuff, then look at the advanced stuff, see where I need to go, and then point out these weak points that I have and watch a bunch of different videos on them until it finally clicks. And hopefully it doesn't take that long, but then work on the project after.
In a certain way to use variables, and I'll show you that. So you don't have to worry about this getting off your computer. But anyway, so the way we're going to query the Bitcoin blockchain is we're going to use an API called NowNodes API. And so all you have to do is go to nownodes.io, and you can get a free API key just by putting your email here. I've already done this, so I'm not going to do it right now, but it's that easy.
Color equals color green. Here green is the enum variant such a color variable. Okay, that's basically what I mean by active. Okay. I'm not sure if I completely got it. I think I understand what you're saying, but yeah, to understand exactly, really understand how it works is gonna take time, I think. You can't have let color green and color red. Oh, okay. But then if you're using structs, you can. So if a struct with a caller attribute, you can point to different things. But if it's an enum, you can't. I think I kind of get it. But again, it's going to take time to understand.
And you can look up all kinds of information on blockchain. So once you've generated an API key, if you know how to use Postman, this is super easy to use with Postman. If you want to test this out, if you want to explore this API some more, all you got to do is go to docs.
Yeah, of course. It's usually like that. When you face the problems, then you get the pain of going through the process of debugging or figuring out what's wrong. That's when you really learn how to do it. But it is helpful though to have this initial contact or whatever you want to call it, because it helps. It's very hard to go from 0 to 1, and I think that's with any language or anything. So it's because usually you have no idea where to start. So having this first initial impression is gonna help me at least come up with something when it's time to code or do something or work on the project that I have.
And then click Run in Postman. And what that's going to do is that's going to actually download the collection, which you can see I have right here, to your Postman app, and you'll be able to use all these different requests. And you just go into the group here, and you just put your API key in just like this. You write API-key, and put your key right here in the value section. And that will give that authorization to everything in this group here. So all of your requests here will be able to inherit this off. And you'll be able to set this API key. And you'll be able to use all these different GET requests and see what's going on the chain. So to start, just to show you what this is going to look like, if we hit the status endpoint, there's no payload or anything, we just hit GET. You can see it gives us information about the Bitcoin chain. So what coin we're using, Bitcoin. And then if you scroll down, what chain, main. So we're going to get some information from this request to talk about like what chain we're on. And then you saw the next is we're going to look at our wallet address stuff. So if you just put in an address up here in the URL, you can get back information about your wallet. And there's just a little example wallet I have. And here's 3 transactions that I've conducted. And so with these transaction hashes, we can actually go to the get transaction, plug it in up here, and hit it. And you can see it'll give you the whole transaction or give you the block that your transaction is part of. So super cool. And these are the 3 endpoints that we're going to use in our app here. So feel free to download this collection and to mess around with all this stuff. There's a lot of different endpoints in here. There's 2 different APIs actually. So go crazy. But we'll come back to this Postman screen a few times as we talk about what we're doing in Rust. So let's dive into the code. So now we're back here in Visual Studio Code again, and we're using the same project that we had before. You see our previous 2 applications in here. And of course, what we're going to do is we're going to do cargo new. And I'm just going to call this thing blockchain info app. So we'll generate that new cargo project. You can see what's created up here. And now we're going to take a look at how we start building this thing. So the first thing we're going to do is we're going to actually pull in a few dependencies that are going to help us do a few things with this app. So first of all, you're going to need dependencies to make REST requests. So you're going to need some libraries to be able to hit those endpoints from now nodes and get the information back. So what that looks like is we're going to put these 3 dependencies in here. And just so you guys know, I'm going to copy some of this stuff from my GitHub. The code is available on GitHub in the description. The link is there. Feel free to take a look, and you can copy paste some stuff as we go. Don't be like typing everything out because some stuff is going to get a little extensive. But in a nutshell, what these dependencies are doing is they're allowing us to make requests. That's what requests is going to do. And then Tokyo and the async STD. Tokyo is really going to enable you to make asynchronous requests, so that you don't necessarily have to do them one by one. You do them on multiple threads, which is called parallel processing. But we're not going to dive a whole line into that. But bring these in, make sure you get the versions correct because they do need to be compatible. And so when we go and hit these endpoints, you can see that we're getting a JSON payload back. So what you can do in Rust and actually in a lot of programming languages is you can actually serialize these JSON bodies into objects. And so if this looks at all like familiar to you after we've covered structs, then that's extremely astute, because what we can actually do is we can deserialize this JSON body into a struct object. And that's like one of the big uses for structs, you know. So we're going to see that live. But in order to do that, in order to take a JSON payload and convert it into a Rust struct, we're also going to add these bad boys here, which is called Saturday. And these are different Saturday libraries. And that's basically what this is going to enable us to do, is turn our JSON bodies into struct objects and be able to use them in our Rust app. Now the last dependency I want to add, I mentioned this a little bit, is the ability to use environment variables in your application. We're going to use .env. So once you got all these in there, go ahead and save it. And next time we do a cargo run or cargo build, these will all get pulled in. So let's go ahead and just take a look at that real quick. We'll see the blockchain info app, and we'll just do cargo build. And we'll see all that stuff being imported right there. Awesome. So now while this is going on, I'm going to flip back to the app here. And for the first time, you guys are going to see how to use multiple Rust files in the same application. Like we're going to drive this thing from main RS, but we're going to have other Rust modules in our source folder that we're going to be able to use. So you're going to get a good taste of what that looks like. So to start, we're going to ignore main for now. And we're going to create some Rust files that are going to actually hold our structs that are going to process information from those payloads. So the first one we hit was the status endpoint. So let's just do blockchain status.rs. And let's go back to what that looks like. So this is what our payload looks like here when we hit the blockchain status endpoint. So what you want to do to be able to deserialize this is you want to create a struct that actually has matching fields. And it's pretty much that simple. You add an annotation and you create the structs to mimic the structure of this JSON body. So we're going to do exactly that. Now, like I said, a lot of this is on GitHub, and I'm not going to make you guys watch me type out the whole struct. So I'm going to copy it in, and we're going to talk a little bit about what's going on here. So for starters, our payload is broken up into these 2 attributes, a blockbook and a backend. So our main struct that's going to process the status information from our payload is going to look like this. So you can see that we're basically creating those 2 fields as attributes, and we're actually making them data types of other structs. And that's how we're going to be able to create like structs embedded in this body here. So like this, you basically look at curly brackets. This is going to be one big struct, and inside it we're going to have a blockbook struct and a backend struct. So again, I'm going to utilize the copy paste, and I'm going to throw in my pre-built backend and blockbook struct. So bear with me one moment there. Now, once we got these in here, you can see that I've had these commented out, and that's because what's going on here is in order to be able to use these attributes in other areas of our Rust application, we need to make them public. And that's what this pub keyword is going to do. So we make the struct public, and we make the attributes that we want to use public. Now, in this particular application, I'm not going to use all of these attributes. I'm presenting them to you guys here so you can see like this is how you do it if you want the full payload. But if you just omit these, Rust can still do the serialization based on the name of your attribute. So it's super, super cool. Like we only include coin in the blockbook set. Like this is really only going to look for this particular attribute coin. And it's not going to care about the other stuff because the name doesn't line up. So it's really, really cool. It does that all automatically. But I encourage you guys, like I include these in the GitHub and in the video here because if you want to mess around and like write more code and like build on top of this and experiment with some of these fields, it's that easy. But for the sake of this tutorial, I'm going to comment these out to sort of preserve a little bit of memory and all the warnings Rust is going to give you since these fields are never read. So now we've got our structs. You can see the structure here is exactly the same as our JSON payload. And you can see like I went ahead and did all the variable types, the data types. So I'm going to strings for all the strings, obviously, and the booleans for the booleans. But anything that was a number, I just did in I64. Pretty lazily, mostly because I'm not using these. But you can feel free to go ahead and put in different size integers. You can do sign, unsigned, whatever you want to do. I just went with I64 for convenience and because I'm lazy. But anyway, so this is super cool. We got this set up to pull that JSON payload. But how do we actually tell Rust to do that? Like, is it just happen automatically? Do we just automatically pipe a response from a request into a struct? Well, kind of, yeah. All you have to do is tell Rust with what's called an annotation. So we're going to add this annotation right above our struct here. And we're using that derive module that we saw in Cargo Toml and deserialize is the trait we're going to use. So we're going to, because we're including this, Rust is going to be able to identify the struct as deserializable from JSON. And that's really all you got to do. You also want to add this annotation here so that Rust recognizes the camel case naming convention of the JSON. If you don't know what camel case is, you see how it's written here. The first word is a lowercase letter, and then any subsequent words that are part of that name, they start with a capital letter. You can see that's how it's structured in each of our fields of the JSON payload. Awesome. So if we just make sure to include those annotations right above each of these structs, then we're good to go. And that's all there is to it. So we're going to do the same thing with the status endpoint, like we're doing here. We're going to do it with the other 2 endpoints that we talked about as well. So get address, right? Like here's all of the fields that we have for get address. Now we'll go ahead and create a new file, and we'll just call it blockchain address.rs. And again, we're going to do the same thing. I'm going to copy paste this in. You guys already know what these annotations are doing, so I'll include those. But take a look at this. This attribute here is actually a vector. Well, why is it a vector? Well, we talked about how vectors are very similar to lists, and in Rust, that's basically what they are. And here, for transaction IDs, we actually have a list of strings. So we can't just do one big string because it just wouldn't deserialize, right? We have multiple strings separated by commas that we put into one string. We don't want that. So all you do is make a vector of strings. And now our vector will contain each of these transaction hashes. So that's pretty interesting too. Again, I commented out any attributes we're not going to need. We'll save that. Let's create our last file, which is going to be blockchain transaction.rs. And just like before, I'm going to copy it in from what I have on GitHub. Feel free to do the same. And there it is. So let's take a look at that payload, make sure we're up to speed. So this payload is pretty large. And like this one here, this transaction that I've created here is on the smaller end. But if you just pay attention to the structure, it repeats, right? So like we have our main JSON payload with these three fields up here. And then you just follow the lines all the way down. There's this additional field, the out, and then there's these ones down here. So we represent all those right here in the blockchain transaction struct. And then if you take a look at the out, we actually have an object here, another struct, which is going to have its own attributes. And you see there's a list in here. So we're just lining all that up. And so here's the out. We got a vector of strings like we saw already. Cool. And then the in is very, very similar. You can see, if you're not familiar with JSON, you can see that each of these is an object with these curly brackets. And inside this like array syntax is actually a list of objects. And these are all going to be the same. You know, like they're all objects of the vn attribute. So these are all the same, and we're going to represent each of those objects with vn. And then you can see down here, both of those are going to be vectors. So we got a vector of vns and a vector of the outs, and that allows us to capture this whole list of objects for each of these attributes. Awesome. Hopefully that makes sense to you guys. If not, bear with me because when we start doing things with these structs, you'll see exactly what's happening and all the magic that's going on behind the scenes. But the bottom line is, this is going to convert plain old JSON from a REST or HTTP request and put it into Rust objects to allow us to just write Rust code on and do what we want with these values. So in the next video, we're going to start laying down all the functionality of that and doing some stuff with these structs, and we'll take a look at the serialization in real time. Hey guys, welcome back to my Rust beginner tutorial. And we're going to pick up right where we left off on the blockchain info app. So we just created these structs and we're ready to start deserializing the JSON payload into Rust objects. So we talked about how our main RS file is actually going to import all of our other modules. So let's stick with that pattern and let's just create another new file. And this one we're going to do all of our like HTTP requests, and we're going to create some functions that are going to actually do the calling of that now knows endpoint. So we're just called blockchain info. And with that created, let's start developing the act of going to that REST endpoint and getting information. So we're going to use request, we're going to use Tokyo, and we're going to use Saturday, and we're going to use result trait. Okay, cool. So now let's define a constant for our entire like module here. And we're just going to make that like root URL string. So we're going to make it a string slice. And this is going to be that endpoint from basically from the status one. Like this is going to be the one we're going to want to use. All the other endpoints are built right off of this root. Like once you get that API part, that's where things start to change. So we'll keep that in a constant and put it up at the top here. And now as we go, we're obviously going to rely on making multiple calls to the API. So let's make one method that we can reuse and do those API calls. So we're going to first do a public method or public function. Let's call it send request. And it's going to take the URL as a string slice, and it's going to return to us a string. Now in it, here's where we're going to use request. So let's do let client equal request client new. And this will create a new client object that will come pre-configured with all the components that we need to make calls to our API. So to do that, you just type client.get, since we're doing a get request, and we're going to just hit whatever URL we're passing in up at the top. So there's a couple things you got to do in Rust to handle different things like that, and we're going to cover that as we define this function. So I'm going to space these things out by just doing this and drop them down to a new line so we can cover each item that we're going to add here to our client command. So the first one's going to be get. That's going to build a basic get request. Now we have to add our API key to the get request in order for it to be authenticated. Like we had to do it in Postman in order to get these responses. So how do we do that in Rust? Well, you want to have what's called a header. So we're going to create a header, and just like you saw in Postman, the key is going to be API key, and now our value is going to be our API key. But we talked about how we want to not have this be a hard-coded value. We want this to be something that is hidden from like just anybody being able to read it. So I alluded to this earlier. What we're going to do is utilize the .env package here. And what .env allows you to do is obviously pull in environment variables. But where do you define these? Well, there are Rust modules that allow you to just have environment variables like on your system, or if you're using Docker, you can have them in your Docker image. But what we're going to actually do is create a .env file. And that file goes not in your source folder, but in your cargo folder. So in blockchain info app, we're going to create a new file called .env. You can see Visual Studio Code recognizes it as config. And all you want to do is just type API key equals your API key in double quotes here, just like I have it. This is exactly what it should look like. So I went and added my API key to that .env file off screen. So once you got it in there and it's in quotes, you can change this here to actually use our .env module. So just type .env var and then the key, and we set it to API underscore key. So now .env is going to pull that in for the .env file. But this is actually going to be implementing the option like we've seen before. So what we're going to do is we're going to do a little like shorthand way to handle an option that comes back as none. So in other words, in this case, if .env goes to try to find that API key value in our .env file, it's not there. We're going to do .expect. And expect is just an error handling tool. And we're just going to say could not find API key. Pretty simple. Could not find key API key. So if you get that comes up on your terminal, Rust will actually what's called panic, and it will stop your application, and this is the output that you'll have. You'll know that okay, I wasn't able to get my key. Awesome. So we built a header for this, and we're going to be able to successfully authenticate with our API key. And now we're just going to send that request as we build it. So in order to send requests, since we talked about how we're using Tokyo and stuff, you actually want to add this await key. Now, I just want to point out there's other ways to do REST calls, but I felt like from my research, this was by far the easiest way to do it. So if you can handle just sticking await in there because of the parallel processing, you're going to be fine. So before we go any further, since we mentioned that Tokyo's going to be conducting this, what we want to do is actually add a Tokyo annotation. So we're just going to add a hash and a bracket, Tokyo, and main. So that's going to be our main Tokyo function there. And because we're using Tokyo, you want to make this an async function. That's beyond the scope of this tutorial, but in a nutshell, like I said before, it's going to make it asynchronous. You can conduct these REST calls sequentially if you're not asynchronous, or if you are asynchronous, you can do them in parallel. Anyways, that is enough to give us what we want from that endpoint. Now, we also want to add this expect key in case that endpoint fails. So we're going to say fail to get response in here, and we're going to handle the error that way as well. Now, one more feature we want to add is if we make it this far and we don't throw panic on this fail to get response section here, we want to actually convert the payload that we get back from that API call into text. There's just that text keyword there. And so then you're going to just add the await and the expect, and I'm going to just say fail to convert payload. Right, so now that this is set up, you can see we omitted the semicolon, and this is going to be a string text. So we're good. We satisfy our return value, and this is what our function here is going to kick back anything that calls it. Excellent. Now that that's set up, let's see this in action. So we're going to just quickly define function, and we'll store our functions in here, just for simplicity's sake, and then we'll drive them all from main. So we just do a blockchain status request. I'm not going to pass any bars into that, and we're going to return that blockchain status struct. Now we can't do that without pulling that into our application. So what we need to do is actually go ahead and import it. And real quick, I just want to call out this import is supposed to be Saturday underscore JSON and then the result trait, not just Saturday. So make sure you correct that. That will allow us to do the serialization properly. So like I said, we need to actually also use from our current crate, so the crate keyword, the blockchain status struct. And that's what that looks like. You want to pull it in from another Rust file that's in your source folder. So really quickly, I'm going to add all three ones we're going to be using, just so you guys don't see me do it again. So that's going to be our status, our address, and our transaction. Now, right now, this isn't enough to use this in a separate file from main, right? Like this module itself, blockchain info.rs, knows that it needs these things from the current crate. But in order for them to be in the current crate, we actually need to do a little bit of configuration in main RS. So you got to think about it like this. Main RS is the root, and it's going to tell your Rust application all the things that it needs to know. So when the blockchain info module is saying it needs to use these particular items from the crate, in main, you tell it that that crate includes them. And that looks like this, the mod keyword. That means bring in this module. So this is what we use to bring in other Rust files. So we're simply going to just add mod, and we're going to tell main that we want to use our other Rust files. So very simple, we're just going to type the name of the file. So blockchain status. We'll start with actually blockchain info. We'll get all four of those. So our main function that we're writing over there, and then we'll also do our status, our address, and our transactions. Cool. So now that that's done, we also need to tell Rust that we're going to be using Saturday, and that that's part of a different crate, not our own. And we did specify in cargo convol here. But what we need to do is we need to actually tell it, okay, we want to use the macros from that module. And you add this macro annotation, macro use, and then extern crate, and we're going to do Saturday derive. Now this will bring in the macros from serialization that will allow us to do the serialization that we've been teasing at. Nice. So I hope that's not too much to unpack, but this is in a nutshell how you tell main to include all those files, and that will in turn make these use declarations valid. And really quick, just make sure that you have the different modules in here. When I copy paste it, I want to make sure that you guys change this over to address and transaction here so that we get the proper imports. So it should be coming from each module individually. So let's go back down to our method. Let's just take out this return type for now so we can see what's going on with that payload. So for some of you guys who are pretty astute and may have been spotting something strange here, why are we going to text if we're going to be going from JSON to a struct, right? Like that's kind of strange. Why are we returning a string if that's what we're going to be doing? Well, it turns out, as we'll see, that string, this text function here, it actually is going to produce a string representation of the JSON object. So you'll see that it's separated with like brackets and stuff, and it's a string that is easily convertible to a JSON in the compiler. So we're going to take a look at what that looks like completely. So anyway, back to the method, and we're just going to type let response equal send request. And so we're starting with just the status endpoint, and we already talked about how like this is the endpoint right here. We're just going to be able to pass in a reference to that host root value, and that'll be the entire URL that we need to get the status. And so we're just going to want to take a look at what's going on here. So we're going to print line, and we're just going to print the response. So you can see what I mean by like that string representation of a JSON. So save that. Now over here, we're going to take out hello world, and we're just going to reference that module blockchain info, and we're going to specifically reference this function blockchain status request. And notice since we made them all public, we can do that. Like public, we talked about with the structs, that allows these things to be used across modules. So we don't pass anything in, save it, and let's just see what happens when we do a cargo run. Get a couple of warnings, but right here, you can see our output is that whole body, the same body we saw in Postman here. And this is what I mean by being a string representation of JSON. You have all the brackets, all the colons, everything's enclosed in quotes. So this is parsable by your compiler and by different modules you use to turn it into a JSON object. So that's why it works as a string in that particular method that we're using. So I'll clear this out, and let's go back to what we were doing. So we had our return value as the blockchain status. This is going to make that little thing out. Okay, so blockchain status is our return type. So we're going to get rid of this print statement here, and this is where the magic is going to happen, ladies and gentlemen. This is where we're going to see that conversion from the payload to the struct. Set to JSON from str. We're going to reference the response value, that string. And now since this is, again, another option return type, we're going to have to add the expect keyword. And all this is really doing, like I said before, is just a shorthand for how you want to handle errors, and automatically will just throw a panic and stop your app. So if that happens, we're going to say fail to parse JSON. Nice, we're going to omit the semicolon because this whole line
It's actually very, very similar to Python in some ways.
here is, if successful, going to create a blockchain status object with our fields from the payload. So let's flip back to main, and let's take a look at what that looks like if we write it a little bit differently here. So let's just, I guess we could take this and say let blockchain status equal this method here, and we'll specify the type as blockchain status type. Now, before we go any further, we told blockchain info as a module that we were going to be using the blockchain status struct, but we didn't tell that to main. We told to import these modules, but we didn't tell it that we're going to be using anything here. So we also have to add those use keywords here. So it's literally the exact same thing you see in here. You can literally copy paste them. You need to tell main the same exact thing. And now this becomes acceptable to use. And so once we've done that, let's just do like a print line, and we're going to say, let's put a little message there. We're going to say querying, and a variable there, chain, and what we're going to pass in there is actually we're going to say querying whatever coin, now it's using Bitcoin, on chain, and we're going to be on main. So this is where we're going to reference the attributes of our struct. So we saw that our struct contains these substructs, and inside them our active attributes are going to be the coin and the chain. So to access those, we saw it in struct work from the videos in the past. We're going to just reference the struct that we get back, blockchain status, and then dot blockbook dot coin. That's going to give us the coin. And again, reference the same thing, blockchain status dot backend dot chain. And now if we print that out, we're going to get the information from our response about the chain. There you go, querying Bitcoin, chain, main. So you can see that totally worked. We totally just converted a JSON body into a struct and then returned it to this method, and we're able to reference the parts of that struct, the attributes, specifically using Rust syntax. So this is incredibly powerful, and this is a great segue into the rest of the application where we're going to actually use these same processes to build out the full app that you guys saw in that diagram from the previous video. Hey guys, welcome back to the Rust tutorial, and we're going to be picking up where we left off on the blockchain info app. So we just saw our first request successfully made to the API, we got information about chain, converted it to a struct, and we did some stuff with it. So let's follow that same process, and let's implement the rest of our application. So step 2 is going to get information about a wallet. So let's go ahead and build that. First, we're going to go back to our requests here. I'm just going to create a new method. I'm just going to copy this one because it's going to be very similar. And we're going to say, instead of blockchain status request, it's going to be address request. And we actually want to pass in an address. We'll make that a string slice. And our return type, instead of blockchain status, you guys did blockchain address. Now, the endpoint is going to be a little bit different. We're still going to use our root here. But once we go up to this API slash, we got to go see in Postman what we're using here. So get address, it's API slash v2 slash address slash your entered address. So what we want to do is actually concatenate the string slice with that other piece that we talked about and the address that we entered. So they're all string slices, and this is how you do that. So we're going to reference, but we're going to reference this whole bit in an array structure. And so you got the host root, we're going to add v2 slash address slash. We're also going to make a reference to our address. Now, at the end of that array structure, you just type dot join. And this is what's called a delimiter or joiner, and this is basically what you would join each of these strings with. So if I put something like an equal sign, it would stick an equal sign between the host root and this, and then between this and the address. But we want nothing there. So it'll create for us the full URL. So everything else is exactly the same. We can keep this whole bottom line exactly the same. And now let's go back into main RS, and let's go ahead and actually do some output here that's going to show us what we're getting from that wallet lookup as well. So here we're going to type, let's do let blockchain address, which is going to be of type blockchain address, equal blockchain info, blockchain address request. And now here we need to type in an address. So I'm going to put this address variable in there for now, but we haven't defined that yet. So again, we want to make use of that .env feature so that we can hide this address. Now, address is not necessarily sensitive, there's nothing we can do with it, but just as like an example of like best practice, I guess, we're going to demonstrate that again with .env. So first what I'm going to do is I'm going to cut this out of main. I'm going to create a new function. And I'm just going to call blockchain info app. Same name as our application. We're going to get the address as a string slice as part of this function, and I'll stick this stuff back in there. So now address is being passed in here, and we're going to run it right here, and we'll just quickly do a print statement, and we're just going to say like analyzing transactions for Bitcoin address. And like I said, the address is not super sensitive, so I'm going to print it out, but if you guys want to, you definitely don't have to. And again, we're using our struct, right? Like just like we did up here, where we're getting attributes coin and chain from our blockchain status struct, we're again going to get the wallet address from our blockchain address struct. So you've seen this before. Now we need to pass this value in, and we need to do it with .env. So in main, let's just do let entered address equal .env var, and our key is going to be all caps wallet. And again, expect error reading env var, something like that. And then with that entered address, we're going to fire off the blockchain info app method and fire in the entered address. Cool. Now, as we saw before, you're going to want to go to your .env file, and in it, we're just going to go ahead and create that same thing, like you do with API key wallet equals, and then just put your wallet address here in quotes again. Nice. Now I've gone ahead and added my wallet off screen, but regardless, I guess it doesn't matter to print out, but this is going to do exactly what we talked about. So let's give it a run. And now we're kicking this off. You're going to see the outputs that we saw earlier. We're querying Bitcoin chain main, analyzing transactions for Bitcoin address, and there's the address I stuck in there ever so secretly. Nice. Okay. So we're successfully reading the attributes of our status struct and our wallet struct, and now let's implement the rest of the logic. So first of all, let's dock up some of this functionality here in this main, function here. So first of all, if you notice that all that stuff is printed out the same.
Right back.
what we can actually do is we can tell Rust to sleep for a minute. Well, technically we're going to do 2 seconds, but still, that's pretty simple to do. So we're going to add a couple of imports up here. We're going to say use .env, and we're going to use a couple different traits of std. So you've seen std.io, but rather than doing these all on different lines, what we're going to do is actually add this curly bracket. And we're going to use io, we're going to use the red, and we're going to use time. And that's how you do all of those in one line. Now, additionally, you can see we're starting to accumulate quite a bit of use keywords. So what you can actually do, a little bit cleaner implementation, is you can just do use with a curly bracket, and then you can declare each of these inside the curly bracket, and add a closing bracket with its own closing semicolon, and then just convert all those semicolons into commas. And that is a valid use statement as well, and Rust will know as a glob to import all of these. So pretty neat, just like cool little concise way to do it. But anyway, so now what we're going to do is we're going to tell our application to sleep for, let's say, 2.5 seconds, just to let the user output be a little bit more friendly. So let sleep time equal time, there's that time module, duration, from millis, and we'll do 2500 millis, which is going to be 2.5 seconds. Seems fair. So then the actual command to sleep the program is thread sleep, and we're plugging sleep time created. And now that will sleep for 2.5 seconds. And once it's done sleeping, we're going to print out, let's say, you have a total of blank transactions. Now, how do we get the total transactions? Like we know from the return value, like from our blockchain address struct, we have a vector of transactions. So how do we count how many are in the vector? Well, there's a built-in method to do that. You can actually just do a reference to the blockchain address struct. And since that attribute is going to be txids, we're going to reference txids dot length. And the length is going to tell us how many transactions are in the vector. Nice. So now that that's done, we're going to give this a run. And here's our original output. Wait 2.5 seconds. You have 3 transactions. And for that while I use, you can see that there they are right there. There's the length and there's each of the hashes. Okay, sweet. So now we said we were going to do something with those hashes, right? We're going to look them up. So yeah, it's cool to print out the length right there, but let's also use each of the transaction IDs in the vector to do stuff with. So you saw I imported std.io, which if you remember we used in a previous video to take user input. I thought I just wrote that into this. So what we're going to do is we'll do a print line, and we're just going to say, do you want to query these transactions? Just give people the option. If they don't feel like looking them up, then they don't have to. And when we ask that question, we're going to obviously expect some user input as a y or an n to tell us to proceed. So just like we've done in previous videos, let the mutable variable equal to command equal a new string. And then of course we're going to do io stdn dot read line, and we're going to reference the mutability of command and override it. And if we get a yes, the command dot trim dot eq equals y, then we're going to proceed with the application. Now this is the part where we're going to start looking up those transactions and pulling some information from them. So just to start, we're going to say we will look up the following transactions. And just like we mentioned, we're going to start actually using the different hashes in this transaction IDs vector. So first we're going to quickly do like thread sleep, and I'll do the same like sleep time again. And once that's done, we're going to print our transaction hashes. So in order to print a vector, you can actually use this syntax here. We can use the colon, the hash, and the question mark. And that's going to do a couple question marks. That's going to do a couple things. We talked about how this with the question mark handles options. When you add the hash, it also beautifies a vector. So you've got 2 things going on there. If the vector happens to be empty, you'll print none. And if it isn't empty, you got that beautifying aspect, which is just going to make it look cool and not look like a funky typical vector. Not super important. But anyway, we'll reference our blockchain address struct again. And this time we're going to take the whole vector txids and we'll print it out. Nice. So you guys know what that's going to look like. I'm not going to write right now. Let's go ahead and do the final REST call, API call, that's going to give us the transaction information. So again, we can copy this address one that we wrote. And this time, instead of blockchain address request, blockchain transaction request. And we're going to input a transaction hash, again, as a string slice. And our return type is going to be a blockchain transaction struct. Nice. Now, let's just take a look at our URL again. So if we go into transaction, we can see again we have the v2, but instead of address, we have tx. So we'll change address to tx. And then obviously our variable is now called transaction. So that's going to give us the proper URL to look up the transaction by hash. And same return type of syntax here, we're going to get the transaction struct. Cool. Now back on our main function, once we print that out, I guess we'll do another sleep. We probably don't need to sleep up here. We'll do sleep, and then we're going to say let mute balance of I32 equals 0. Now, here's where things are going to get a little bit tricky, but I promise if you guys follow along, you're going to understand what's going on. If any of you guys programmed before, this will be very familiar. But what we're going to do is initialize this mutable variable as a balance. And then every time we look up a transaction, we're going to get some information about it, and we're going to add this balance, and we're going to try to guess what that Bitcoin address balance is right now, based on all the information on the chain. So for starters, what we're going to do is iterate over each transaction ID in, and we're going to make a reference again to the blockchain address.txids variable, that vector. So iterating over that, we're going to do a couple of things to calculate basically the Satoshi's in and Satoshi's out. So I don't really know why it's represented like this, but from my research, I noticed that V out is actually Satoshi's in, and V in is Satoshi's out. So I'm not really going to try to ponder why that is, but if you notice that it's kind of backwards, that's why. So now we're going to continue on, and we're going to go through each of these transactions. And basically what we want to do is for each, we want to take the V in and the V out, and we want to get the value for each of those, and just do a simple like summation. Like we want to get like in minus out and come up with the sub balance for each transaction, and then add the sub balance to our total balance. So to do that, we'll let the subtotal of V in, again, another I32 equals 0, and we're also going to let the subtotal be out equals 0. And every time we get a new transaction, we'll set the subtotals back to 0, which is good. These are subtotals, that's what we want. And let's say we add some logic here. At the end of the logic, we're going to add to the balance plus equals is going to take the value of balance and add something to it. We're going to add the subtotal V out minus the subtotal V in. Cool. Now what we're going to do is actually add the logic to look up each transaction. So right here we put this comment. This is where we're going to fire off that request that we wrote here. For each transaction in the vector, we're going to look it up on the chain. So that's going to look like this. We've seen this already above. We're going to do let blockchain transaction, and that's going to be of type blockchain transaction, equal blockchain info, blockchain transaction request, and we're going to reference that txid from our iteration. So that's going to give us the struct of the blockchain transaction. And like we've been doing, we're going to just use the fields of the struct to do our calculations. So we know that this transaction, when you look it up by hash, like there's going to be a lot of people's transactions in here, and like only a couple of them based on what you did are going to match your wallet address. Like some of them are going to be your wallet. So we need to actually match the wallet that was entered in the app to any wallets on that transaction block that match it. So let's do let match address equals string from address. Now this is the last time that we're going to need the address variable. It was actually up here at the top. It was used to look up the address and get the information back, but now this is the last time we're going to need it. So we're going to actually destroy it. But since we're going to loop, it's not going to be destroyed until the loop finishes. But nonetheless, we're cool with it. So now that we've got our response blockchain transaction and we've got an address to match the hashes to, we're going to do both the v in and the v out one at a time. And we're going to simply do Satoshi's in minus Satoshi's out and add that to the sub balance. Then we'll print the sub balance out and add it to the total balance. So that's going to look like this for tx in, and we'll reference the blockchain transaction. And that's going to be struct again. And we're going to reference v in. So for each transaction in v in, if the transaction dot addresses dot contains match address, then we're going to add subtotal vin. We're going to add to it the transaction dot value, and we're just going to parse this from string into an I32. And that's just in case like we for some reason get back string, because in here in the JSON, value is actually represented by string. I'm not really sure why, but we're going to put it into an I32 and just do unwrap. So there's kind of a lot going on here. I'm sure you can figure out the gist of it, but basically tx is represented by each item in the vin vector. So if we look at our vector here, we've got a vector of vn. So each tx is going to be a vn struct, and we want to get the value and we want to match the addresses. So addresses is actually a list, so that itself is also going to be a vector. And so we just want to look if this vector contains the string of our address. If it does, we're going to add the value. In this particular use case, it seems to me like addresses are always going to have one item in them, but if they don't, like your logic may change a little bit. For simplicity's sake, let's just pretend that they all have one address in the vector. Anyway, going back to what we did. So this is going to append to the subtotal any values that are detected that match our address. Makes sense. And we're just going to copy this loop because we'll do the exact same thing for v out, and we'll make sure that we add it to the subtotal v out. Nice. So there you have it. Now after we append to the balance the difference between the two, the sub balance, what we want to actually do is a little bit of a printout that's going to talk about the details of that transaction we're looking up. So I won't make you guys painstakingly watch me type this, copy it from my GitHub, but this is kind of what our output's going to look like for each transaction. And then as you can see, here's the transaction ID from our blockchain transaction entity, And then here's our subtotals that we've been calculating throughout, and then the balance at this current transaction. So for each iteration of this loop, we're going to see this print out. It's going to detail the current transaction. And then at the end, when we're done with this loop, close it with a semi, we're going to actually add this print statement here. And this is going to print out the current balance. This one will be in Satoshis. And as you can see right here, we added the conversion for the balance in Bitcoin. Nice. So as we saw, we're going to go through each transaction in the vector, look it up, and we're going to calculate the subtotals for each V and V out, and we're going to print this stuff out and eventually get the current balance. And that's it. That's a wrap. Let's see if this thing works. Looks like it's going to work. There you go. Querying Bitcoin chain main. You have a total of 3 transactions. Do you want to query these transactions? Yes, we do. There's a transaction we're going to look up. We're going to time sleep, and then there you go. Printing out information about each transaction, and then the balance. And just as a side note, that actually is the balance in my particular wallet. That wallet is just like a side wallet I have as an example. Don't pay me some for. But as you can see, this works. And like I mentioned before in the previous video, if your address is using the same address every single transaction, you can do this with your own wallet, and it'll give you your current balance in BTC. So congratulations, you guys just built a more robust sample app. This one is actually doing crypto stuff. So this is the end of the playlist for Rust tutorial. And if you made it this far, hats off to you. And I hope you guys enjoyed everything that you saw. And stay tuned for more videos and more playlists. Hey guys, welcome back to Coding Crypto, and today we're kicking off the Rust Intermediate tutorial. Now just like a quick note, I'm assuming if you're in this tutorial, if you made this playlist, that you have some experience with Rust, or you've been doing some studying, or maybe you can caught my beginner tutorial. But I want to mention that if you did watch the beginner tutorial, I'm going to move a little bit faster in this one. In that previous tutorial, I made sure I covered everything and I went real slow, but here I'm going to kind of barf out some code, and we're going to talk about everything that's going on, and then I'll give you guys an opportunity to pause the screen and catch up to what's on screen. And as always, the link to my GitHub's in the description, so if you ever need reference to code, it's always going to be there. But without further ado, let's kick this thing off. Today we're going to start by showing you guys how to containerize your applications in Rust. So we're going to use what's called Docker. If you've never used Docker before, you can probably skip this video for now and come back to it once you kind of need to know how to do this. But this is going to be very important anytime you containerize your app and you want to ship it somewhere. So if you want to know what Docker is, there's great videos online. Go check them out. Go do some research. It's a super powerful tool. But here we're just going to dive right in. So we're going to do new project. We're going to call it Rust and Docker. And I'm actually going to be using my WSL.
So I think what I'm gonna do after I watch all these videos is watch the beginner list again and then code along with it, because it's pretty similar to the stuff that I wanna do. So I'm gonna code and then refactor based on the stuff that I have on my own. I think that's gonna be a perfect mix of challenge and yeah.
Terminal for most of this, so I'm not going to really worry about it in here. So now that we've created this project here, you guys know what this is going to generate. I'm just going to say hello world from Docker. And to make a Docker file for a Rust application, you want to put it, I guess you can put it wherever you want, but I prefer to put it in the create file itself, like in the folder for the crate, so Rust and Docker. And we're going to create a Docker file. And if you want, you can check out Rust's official image on Docker Hub right here. I would just search Rust Docker Hub and you'll find this particular image here. And this is just a Linux image with Rust toolkits in it, so like cargo and all that jazz. And you can use it to build your app. And there's a couple examples on here and some good information here. We're going to cover the gist of it here. So I'm going to just type this out and then we're going to talk about everything that's going on here. So for starters, I'm obviously going to just use that Rust image. We're going to create a new cargo crate, just like we did in our terminal here for VS Code. I'll name it the same thing. We're going to set the work directory equal to that particular binary that we just created. And then we're going to copy in cargo.toml. And of course, source. Now, last thing we're going to do is we're going to run cargo build. And we'll do a release build. We're just going to put it in a release folder in the target folder, and it's also going to kind of omit some of that unnecessary junk that can get spit out to the output. Now, just as a side note here, this is enough to build an image here that's going to actually create and then deploy your Rust application. Technically, it needs to look something like this. But this right here is enough to do it. But the thing about this setup is we're actually shipping the whole Rust image with our app. And that means we're going to be shipping like cargo and all the toolkits that come with Rust. And you don't really want to do that with Docker. With Docker, you really just want to only ship what you need. So with cargo, all you need cargo for is to build the application and to install all the dependencies and to manage all the different aspects of your app. Once that's done and it's been compiled into an executable binary, then you don't need cargo. And you don't need any of the other junk that comes along with it. So if you were to ship with cargo, your image is going to be super heavy. It's going to be big. And you can eliminate most of that by actually doing what's called a multi-stage Docker build. And that means we execute all this build stuff up here. And that's why I named this builder, because this is the build stage. And then we copy what we need from the build stage into a new image. And that's exactly what we're going to do. So let's start with CentOS as an example. This is the Linux distro that we want to use. And here's the magic part right here. We're going to copy from the builder. And we're actually going to copy this whole thing here. And we're going to put it into this Rust and Docker executable here. And then our command becomes just that. So now this part here is just the image that we're going to ship. So all it has is our CentOS distro, and then our application. It doesn't have cargo, it doesn't have anything else. And now we're going to just jump into WSL and use Docker to see what's going on here. So as you can see, well, first of all, my stuff is cached, so that's going to move a lot faster on my machine. This may take a while at first, but once Docker kind of caches this stuff out, it can be pretty quick. But either way, you can see that we stepped through each of those steps, and we successfully built our Docker image. So now let's just run it. Hello world from Docker. Nice. So you can see that worked, and this is all we're running right here. So that's super cool. Now what about other like operating systems here? What do we want to use CentOS? What do we want to use Alpine? Well, to start, I'm going to just create a new file here, and I'm going to call it Docker CentOS Docker file. And I'm just going to copy this stuff in there, save it, just so we have a record of it. And now if we go back to our original Docker file and switch this over to Alpine, seems like it's going to work, right? No problem. But actually, what's going to happen is that Rust image is going to be compatible with Alpine, and we'll talk about it. So it builds no problem. But when you go to run it, you get this error. And that's because this Rust image is compatible with a lot of Linux distros, but Alpine is not one of them. So what you actually need to do is use the specific Rust Alpine tag. And that's going to have an Alpine file system when it builds the application, so that when you put it onto an Alpine image, everything is compatible. So let's try that again. And as you can see, it's going to pull in that image because I don't have it on my computer yet, and I'm just going to fast forward here. Okay, so that's successfully built, and now we're just going to run it. And there we go, now we get our output. So that's how you make it compatible. I don't know how many operating systems or Linux distros are compatible with the basic Rust image. You might have to do a little research on Docker Hub, but this is definitely how you do it with Alpine. So we're going to go ahead and create a new file, and just call it Docker Alpine, Docker file. And again, I'm going to copy this in there for an example. And now the last thing we're going to cover is we did CentOS, we did Alpine. Let's go ahead and do Debian. And pretty popular Debian is the Buster Slim. And so just as like a side note, this will work with just the Rust 1.58 image. But you can also use the Buster Slim tag as well. So as you can see, that builds no problem. And hello world from Docker, nice. But just for consistency's sake, you can also do Rust Slim Buster. And that'll guarantee you that they're both using the same OS. So build again, run again, and we get our output. Awesome. And that is really it. I'm going to toss this in a new file again. But that is how you create Rust Docker files. And how you can create Docker containers for Rust. So this will come up later because we're going to build some example apps later. We're going to do some stuff. And you can see the capabilities of Docker and be able to ship this stuff into like cloud, Kubernetes, or Kubernetes iCloud, like what have you. And that'll be a very integral piece. So good way to kick this tutorial off. Thanks for watching. Hey everyone, welcome back. This is going to be video 2 of the Rust Intermediate tutorial. And today I'm going to show you guys a super cool feature of Rust where you can do operating system commands, like basically command line stuff from within your Rust app. So this stuff is dope. Check this out. We're going to use main here. I've already generated a project for the next few videos to put some of these Rust files in. And so what we're going to do is we're going to first use std process command. And I'll set up a little example here. Now this is how it works. We're going to say let echo cmd equal if, and now this is a pretty cool feature here. We're gonna say if config, this config macro, target OS equals Windows. And you can obviously probably figure out what that's doing. It's saying, okay, if we're on Windows, if Rust detects that we're on Windows, then this variable is gonna be equal to this command struct that we just said we're gonna use. And it's gonna have CMD, and we're gonna pass in these args. Now this is specific to Windows, obviously. So all we're gonna do is we're gonna say echo, hey there from Windows, and we'll do output, and we're gonna handle that exception with an expect, and just say failed to execute command. Now I like this stuff to be kind of neat, so I'm gonna drop these down to a new line here. And then I'm gonna just copy this. We're gonna say else, so if we're not on Windows, then we're gonna use sh, and this is actually going to be -c, and we're gonna say ahoy there from Linux, and don't forget your semicolon there. Now I'm gonna just do like a print line here, just to create some space because I'm super weird about the output stuff. But now we're gonna say let the command output equal echo command.std out, and then we're gonna print that. So we're gonna print line, and we're gonna say command output. Now this is gonna be a vector. It's gonna be a vector of U8s. Now what is all that? Well, this is gonna be bytes. So when this stuff is run, these commands are run, Rust is gonna get a byte response from the operating system. So it looks like a vector of numbers, but in order to convert that vector of numbers into like a human readable output, you actually want to go and do something along the lines of this. So string from UTF-8, and that will give it a human readable output, and then we don't need this like beautify filter here. Oh, and by the way, you just have to add expect because this is going to be a result. All right, nice. Now let's just call this function down here, and let's run it on Windows first in VS Code and see what we get. Hey there from Windows, nice. Now if I run from my WSL terminal, if I do cargo run, you can see instead, since we're on Linux, we get ahoy there from Linux. So how cool is that? You can obviously see that you can build on this. You know, we're just doing echo, but you can do all kinds of commands, any kind of like binaries or executable things that you have on your operating system. You can do with Rust. So let's kind of flex our muscles on that here. Let's build another example, and I'll show you how you can make this kind of like dynamic. Like you can use the same object, the same command struct to do more than one thing. Like sort of, you reuse the same object to just keep conducting business on your OS. So I'm gonna add some of these guys because again, I'm weird. And we're gonna say let mutable command root equal command new, and I'm gonna keep this one just on Linux. Like I'm just gonna run this from WSL, so I'm not gonna worry about the whole like configuration thing here. Now that we have this object created, we can actually use this ls command again and again. And this is how you do that. You just type command root dot status dot expect, and for our expect message, we'll just say failed to execute list command. And then to do it again, you can probably figure out what we're gonna do is copy paste here, but let's make it a little different. So right now when we run ls, this Rust program is going to run inside the cargo folder, inside the crate. So in this case, it'll be this intermediate concepts crate. But what if we wanted ls like a different directory? I mean, you could always do like this, but that's not gonna make it dynamic. So what you can do is for the second time you call it, you can actually add this additional sort of argument here, and you can say current dir, probably laughing how I say dir, and let's just make it source. So now we're gonna do an ls command to print what's in the current directory, and then we'll slide into source and we'll do ls again. And I'm gonna just add this thing for the sake of good formatting, comment this out, and again, like I said, I'm gonna use WSL. And there you go. You can see that when we're in the current directory, we can get all the files that are in there, and then we enter source, and we just have main RS in there. So that's how you can kind of like dynamically use this object here. Now, this is a pretty simple example, but this is very, very powerful, and this is used a lot in practice because Rust is very, very close to the operating system. You know, people like to write Rust for systems programming. So doing stuff like this is very interesting and very useful. And you
I think this is one of the things that attract me the most as well. The ability to be able to create programs that you can see on the command line or that are close to the operating system.
immediately see that if you had like binaries or if you want to
I think this is going to be useful for when creating nodes and creating my own node, and also interacting with that node is probably going to be useful.
Or what have you. You can pass arguments into it. Like, we don't just have to run echo. You can run like, let's say some kind of binary and then have additional arguments that are like args that you're passing in. So go nuts with this. Build some cool stuff with it, and we're probably gonna see it again. Hey guys, welcome back to the Rust Intermediate tutorial, and we're gonna be looking at some advanced error handling methods. So I'm kind of building on what we were doing in the last video. You can see we're using this std process command struct again, and I kind of wrapped it into this function that you can pass string slice in, and that string slice is gonna represent the directory that you're trying to run ls for. So you saw in the last video that we just added expect to all of these because I talked about how this was gonna be a result, and I've also gone over result in my beginner tutorial. But this is actually a shorthand way to execute a panic. So as we can see here, if we go ahead and run cargo run, we're gonna get main rs for when source is put in there, but when lib is put in there, which doesn't exist, we get this red main panicked, and we see no such file or directory is there. So that's a shorthand way to throw a panic. And I'm gonna show you guys the longhand way to do that. So to do the same thing, let's take expect out and type the match keyword in front, and we'll say okay, and we'll do a lambda expression that just says like, if this is okay, continue with the command. If it's an error, then what we want to do is we want to panic and just say error, oops, and we'll go ahead and just print out the error with that E representation there. So this is the longhand way to do that. And as you can see, it's gonna look very, very similar. We're gonna get the main RS again for source, and then this time we just get like a slightly cleaner representation. We don't have this like struct object here being printed out. Instead, we just have our message. So pretty cool. But there's more that you can do with like writing your own error handling methods. For example, what if you don't want this thing to panic? And a panic is obviously gonna stop your code, it's gonna stop your application and abort what it's doing. So what if you don't want it to do that? Like what if we want this to just kind of like continue with its business if it's not able to find this directory? Well, you can totally do that. All you're gonna want to do is turn this like match situation here into an option. So when we have this okay part and we're just saying like, conduct the command, change that to a sum command, and then we can drop this panic and just type none. And now we can even get crazier, and we can go like this. Create these curly braces, and we can print line, directory not found, and we can return none. So let's see what that looks like then. Boom. You can see that we obviously found main and source, and when we hit lib, it wasn't found, so we just printed this out, but the program gracefully exited. There was no error thrown, like this didn't panic, nothing happened. So that's a very powerful capability. Now this isn't super necessary, but you can also use the same syntax to do like setting a variable. So if we just did like let x equal, that's perfectly valid too. And you can use this for when you're trying to declare something as this value or what have you. Obviously in our case, this particular command doesn't need to be set to a variable, but you can see that we'll get the same exact result. Now we can also get deeper into the weeds here, and we can match the error type, and we can like do different things based on what kind of error we encounter. So to do that, what we're gonna want to do is make sure we use stdio error kind, and then you just simply add another match statement. So if we just like take this out for now, and we say match e.kind, and then we say error kind, and ours is gonna be not found. That's the one we've been seeing a lot. And then we add the curly braces again, and we put our same error handling stuff in there. And then just like any good match statement, we need to also have a case for all the other possible errors. So like we don't really know what kind of errors this thing's gonna throw besides not found. So we just put this underscore there, and that represents any other error type that could possibly come along. And in that case, we're gonna go with our regular panic, and we're gonna say an unexpected error has occurred. Cool. And as you know, that's gonna run just like we've seen, and it's gonna do the same thing that we saw before. Unfortunately, with the way we had this set up though, since we're using current dir, this is always gonna throw the not found if this is an invalid directory. There's no way to really trigger this particular use case in this example, but that's what will happen. Is any other error kind that comes along, we'll get a panic. Now, we just talked about the longhand way to do stuff, and this right here is your best bet for doing like complex functionality as a result of errors, maybe directing your program into a different kind of sense of direction, or maybe like this is within a loop, so you put like a continue or a break. But let's go back and talk about some of the shorthand stuff. So we'll just drop this all out here, and I'm not gonna have let x equal anymore. And we're back to our original command, and you can see that Rust is already yelling at us because we're not handling this as a result. And you saw, like we did earlier, you can use expect, and we can just do like blah, and that's perfectly okay. And that's, like I said, the shorthand. But what about this other shorthand here, unwrap? Now, unwrap is going to do the same things, except there's some caveats there, but one of the most important takeaways right now is that unwrap doesn't require any kind of message. It's just going to give you the raw error. So as you can see, if we go ahead and do the same thing we've been doing, you get that same red main panic message that we've seen before with expect. They both do very, very similar things. Now, there's one more particular shortcut we could use, and that shorthand is going to be the question mark shorthand. Now, right off the bat, when we put the question mark in there, we see this error here. Cannot use the question mark operator in a function that returns nothing. So this is limited to a function that is going to return something, obviously from that error. You can't use it for just like what we're doing here, like printing it out. So I'm going to do like sort of a hacky way to show you how this works. But basically, you want to set your return type to a result. In our case, we're going to make the result an I32 or an error. And in order to use error like that, you just want to go ahead and import stdio error. So I'm just going to add it up here to our import statement. And now that it's in there, you want to go ahead and return at the bottom of this function, okay. And I'm just going to put 1 in there. Now, you can see Rust is warning us here. They're saying like, hey, you have to use this return type, but you're going to get a 1 back from this. I'm not going to do that because it would cause me to have to rebuild this whole example. But in a nutshell, remember that you're supposed to use the question mark when you're having return values. And you also have to use result so that there's that conditional kind of going on there. But as you can see, if we run this thing, we're going to get the exact same response for source. But this time for lib, which doesn't exist again, nothing happens. We just get nothing at all because we have no error handling going on. It's just run this command. If it fails, if there's an error, then we're not going to return an okay. But you can see that nothing happens. It doesn't panic. Everything's graceful. It works fine. So that's a powerful shorthand, but use it wisely because again, you're going to have to make sure you're doing some kind of return type. This example I have here is a little hacky, and you also aren't going to get a panic and nothing's going to happen. So you got to be able to be prepared for that. And you got to be able to handle that. But that's basically it, guys. That is errors in Rust and error handling. And with these tools that we covered in this video, you'll be able to go ahead and build super robust applications that can handle all kinds of errors and execute processes gracefully in the face of all these different errors. Hey guys, welcome back to the Rust Intermediate tutorial. And today we're going to be talking about generics. So I'm going to slide this thing down here. Now, a generic is a pretty powerful tool, but you got to use it carefully. We'll talk about why. But first, let's type out a few generics that we've already seen. So the first one's going to be option, of course. And this is what an option looks like in raw form. I've already done this before. And this is what a result looks like in raw form. And you can see that they're both using these weird like capital letter, I guess, identifiers. So what's going on there? So they've got this like T and TE, and all that really means is you can pass any kind of data type in here. So if you use an option and you specify it to be a string, you can do something like this. And it's totally okay. If you want it to be an I32, it can be an I32. But instead of like defining all different copies of the same thing, you just put this T in there, and then you can reuse it with different stuff. Now the key is when you use generics and you're using, basically a wildcard for your data type, you have to be careful that the methods and functions that you run on that data type inside your function, like if this was more than just a basic enum, they have to be compatible. And we'll see that going forward. But basically what these allow you to do, and I'm just going to copy in some examples that we've already seen here, like for example, here's an option being used for a particular function there. And you can see that this time we're using a string. So we're able to use some here and put in a string, and then none, you don't need any kind of data type. Now again, if we change this to an I32, you can see the same process as before. And I'll also put an example in for result. And this is just going to be the error handling example from the last video, actually. And you can see here, okay is allowing us to just continue with the command. In this situation, we don't actually have anything going into okay that's like a data type, it's just a process. But our error is still of type E, which is still of type error, right? Like, just because the capital E doesn't necessarily mean anything. But you can see that these are really powerful tools. And you don't have to just use them with enums. Now, you can define your own enums, and you can build the same functionality. Like you can have some kind of custom enum that maybe does something like this. And you can do like a, I don't know, we'll just do like T for an example. We'll just say example of T or sample of T, whatever. But you can see the idea is there that you can create your own and you can have your own, values in there for data types. You can also do something like this, and you can have 2 different types of data types in your enum. And that's what's going on up here in like the result one. So pretty interesting stuff. And this isn't limited to just enums, like I said. We can also do this with structs. So here's an example of a struct that is going to use one particular data type. Let's go with height and width. And you can see that obviously no matter what kind of number, even if we did a string, like we would represent the height and width with the same data type. And just like before, if we wanted to do multiple data types, we just got to come up with different like uppercase representations for each data type that we want to pass in. And in generics, it's just these uppercase letters. And so we'll do height T, width U, and length V. Nice. And that's exactly how you use those structs with generic data types. And here's just an example of that in practice, like initializing these structs. So if we just let rect1 equal rectangle, and we say height is going to be 1, and width is going to be 2, and then we copy that, and we change these to, I don't know, like just make them floats instead. You can see that that's perfectly fine. We can use ints or floats. It doesn't matter because we've got generics. And the same thing goes with the cube. We just go ahead and create a new cube. We can say height is 1, width is 2, length is 3, and then we can copy that, and we can change these to like 3.75. We can leave this one as an int if we want, and we can make this like 1.54. See? All totally valid. So let's recap here for a second. We obviously covered structs and enums, and I went kind of fast because the concept is quite straightforward, right? Like these are just placeholders, and inside anywhere you see one of these capital letters, you can pass different data types. And that doesn't really get complicated until you start to use functions or methods, and you start to have issues with like type compatibility with the different operations you're trying to do. So let's take a look at functions. And when you try to initialize a function with a generic, first of all, it looks like this. You have to type the function name, and then you have to pass in the generic in the function header like this. And then you pass in your object, and you can just have it be of type T. And you can also do like a return value, so like we want to return T as well. But here's where you're going to start to have some issues. Like what if we wanted to do, instead of generic function, let's just do like sum of numbers, right? Now already just calling it sum of numbers, that kind of takes non-numbers off the table. So kind of something to note right there, but let's just say we want to return, let's just say we want to do like 2 numbers, num1 and num2, both of the same type, and we want to just return T. So we're going to return num1 times num2. Now right away we get an error. Now all our types check out, our return type checks out, everything's cool, but what's this say? Cannot multiply T by T. So why not? Well, Rust doesn't know what you're going to pass in here. We haven't written any logic yet, like the compiler doesn't really know. And even if we go ahead and scroll down to main and we just say like sum of numbers, and we pass in a 1 and a 2, it still doesn't work, right? Like it's fine down in main, but we still have this problem up here. And that's because Rust is warning you like, hey, this is a generic function, but this operation that you provided is strictly limited to numbers. So floats, ints, even unsigned integers. So you can't just implicitly apply numerical operations onto a generic because it could be a string, it could be an option, it could be an enum, it could be a struct, it could be anything. So this is where you have to be really, really careful with generics. Let's talk about how we can actually deal with this kind of thing. So I'll bring this up and let's just try to print the result of what we're doing here. And now let's see what Rust says when we try to do a cargo run. So we know that this was coming, right? And it says consider restricting type parameter. And that gives us this suggestion here. So we already talked about why we can't do this, but what is this? Well, this is actually what's called a trait. And basically what's happening here, because we're going to talk about traits in the next video, I'm going to quickly just summarize. This right here is you declaring that this generic type T has to implement this trait. So in a nutshell, since this is a multiplier trait, we're basically saying that I know we're defining our return type to be a multiplication operation. So anything that gets passed in as a generic is going to have the multiplication trait. And that limits it to number of types that are only going to be able to conduct this operation. So if we just go ahead and put this in our function header, just like they told us to, you can see that all of our errors go away. And if we run this, we'll actually get our product, C2. And now that's exactly how you can restrict your types but still use generics. And that's the recommended way to do it in Rust. In the next video, we're going to talk about traits, and this will be a lot more clear. But just for reference, I'm also going to provide a function example that is basically a function that you're not going to need to restrict the data type. But it's tricky because there's not a whole lot of use cases for this because of what we just saw. So I'll give you guys a simple one. Look up data type. And so we're going to pass in generic, like we said. We're going to have object of T, and it's actually going to return nothing. And we're just going to print what the data type is. So I'll just do something like this. And we're going to use std, any, type name. And this is a little bit of like a hack, I guess, because this is one of like the only use cases I can think of where you can have an unbound generic, like completely irrespective of any kind of trait. If you guys can think of other use cases, try them out. But the trick is here, like anything you pass into this, whatever you do to it has to be applicable to pretty much any data type that you can possibly pass in. And so, just printing out what the data type is, that's a pretty straightforward operation. So if we just do like lookup data type and I just pass in like a 1, or if I do 1.96 or 95, whatever, and then maybe I also do a string slice, you can see that when we run it, we're going to obviously get back the data types. So that's an example of how you can use a purely generic function. But this is going to be your best bet here. You're going to want to use traits, and you're going to want to have some kind of restriction in order for you to be able to actually do like operations and stuff within your generic functions. And again, these kind of function rules, they go for methods of structs, methods of enums, associated functions for the two of those, any kind of function. This is the case. So I hope that makes sense. I know it's a lot to unpack, but I think once you guys see traits in the next video, this will all come full circle, and we'll be good to go to start building some really cool object-oriented stuff in Rust. Welcome back to the Rust Intermediate tutorial, and today we're jumping right into traits. So if you caught the last video, we got a little taste of traits when we were working with generics. And basically what a trait does is it allows you to associate certain behaviors and capabilities amongst different data types, usually structs or enums or what have you, but it can be applicable to a lot of things. If you guys have ever used interfaces before in the language maybe like Java or something like that, these are very, very similar. There's just some key differences that we'll talk about. So first of all, to define a trait, you just use the trait keyword, and we're going to define a trait of vehicle. And we're going to have two functions in there that are going to return strings. Now, as you can see, and very similar to interfaces, these functions have no body. They don't have a body because you don't necessarily have to define your function outright. Like when you have no body here, and you're saying like, yeah, it's just got to return a string, then anything that implements this vehicle trait can define its own function. Like you can provide a body if you want. Like let's say, return ignition. I'm getting creative here. It's going to return a string, and that string is going to be vroom vroom. So you can have functions that return stuff. But now because we've already declared this function body, we can't write our own. Like we have to do this. So let's talk about what that looks like here. If we go ahead and build a struct of a car, and we want to say the color is going to be a string, just have some kind of attribute in there. And then we say implement vehicle for car. This is how you cast a trait onto a struct or something else. You use imp and then use for. And so now we get this red underscore here because we're missing forward and backward in the implementation. So we already told it that like, hey, these have to return a string, but you have to define them. But if you notice, that third method that we put isn't on there, that turn ignition one. And that's because automatically this car already has it. So before I even define anything, take a look at this. If I just go ahead and type print line, and I want to do like a car turn ignition, you can see that I don't get any errors. But we haven't described anything in this implementation part here. But that's because as soon as you implement vehicle for car, no matter what you define for the other functions, forward, backward, that we have to define, this one comes automatically. It's already built out with the body, and this never changes. So this is not going to throw us an error. But if we try to do like our other functions, let's say forward, we don't get an error, but we don't have anything implemented for yet. So to do that, all we have to do is just type the function out in here. So let's say forward, going to return string, and the string is going to be driving my car forward. And then we'll do backward as well. I think you can guess what that's probably going to be. We're just going to say backing my car up. And now we can successfully print each of these as their own functions. Now something to note here is these are associated functions because we're not referencing the struct itself, and I'll cover that in a minute. But one of the key features of a trait here is we can apply this trait to multiple structs. So if I go ahead and I add a new struct for a truck, and again, I'm just going to do like a color string, and then we go ahead and implement vehicle for truck as well, and I'll copy this stuff, save you guys the pain, and we just change this to truck instead of car. All perfectly valid, and you can see that we'll be able to actually go ahead and provide each of these for truck as well. And we'll print these out, we'll see what they look like. I'm sure you guys can guess what it's going to look like. We'll do a cargo run, and as our output, we're going to get, as expected, vroom vroom for each struct, right? So it doesn't change, vroom vroom is the same. But when we ran it for the car, it's car, and when we ran it for the truck, it's truck. So I know it's not super overwhelming, but this is a powerful capability. And just like the last video where we were using traits to kind of like restrict our generic data type, there's a ton of stuff you can do with traits for like object-oriented stuff, inheritance, abstraction, all kinds of things like that. However, one thing to note is I mentioned that traits are a little bit different than interfaces. And that's because you can't do something like this. You can't just declare attributes in a trait. Even if it's public, what have you, you can't do it. It's only functions or methods. So that's like pretty much the key difference between an interface. Other than that though, they operate pretty much the same. So now let's go ahead and show you guys. I'm just gonna make a quick copy here. And I'm gonna put all this in a new file. I'm gonna show you how we can do traits that are self-referencing. So instead of associated functions, these would be methods.
Also gonna write down your I'm gonna just add here traits. Because those are really similar. I get that they're different, but I wanna study a lot more of them about them.
And all you have to really do is just add the self-reference. And once you do that, this becomes its own self-referencing trait. And so these become methods instead of functions. Now all that really looks like in the implementation is you have to be referencing the self again. And now we can just do something like this. We can say string from format we use the format macro, and we'll go ahead and just do self.color. And we can do that again down here as well. And I'm going to quickly fast forward while I add this to each of these. And so now that I've added self to each of these obviously become methods now, and they're self-referencing. And it's cool because in the trait, we said, yeah, these methods here are going to reference self. Like, they're going to be methods of that struct self. But the vehicle trait isn't the object. You know what I mean? Like, we're referencing self in the trait here, but we don't have an object declared yet. We don't have an object until we implement the trait on an actual object, like a struct or an enum. And that's still completely fine. Like, you can totally do that. And that will allow you to implement methods as well as associated functions. So you can see we're getting some errors down here. Now, we left turn ignition alone. It doesn't have self in it. So that's still an associated method or an associated function. So you still call it with this syntax here. But in order to use those other ones, we now have to declare an object first. So if we just say let car equal car, and I'll do the color, I don't know, I'll do like string from green.
It reminds me a little bit of abstract-based classes on Python, where you define a class that is just going to serve as a template for other classes, as far as I understand.
And now we can say, with the car syntax, we can use car.
But it's slightly different, I think, in Rust when it comes to traits.
Got. And I'm sure you can guess what we're going to do for truck as well. And there you go. So now let's print this out. Let's see what cargo run gives us. There we go. So it's doing the same stuff as before, but this time we have this self-referencing attribute in here. And these are, as you can see, methods. And that is in a nutshell how you do traits. And we talked about in the last video how these can be used for generics. They can also be used to create objects that all share certain behaviors, which comes in really handy with stuff like building APIs or building like basically any object-oriented program. So take note of this stuff. Again, it's all on GitHub. And if you have any questions, drop it in the comments. Thanks. Hello and welcome back. Today I'm going to show you guys something cool about cargo. So if we dive into a terminal, as you guys have seen before, what we've been doing is cargo new, and then just some kind of binary. But what this is actually doing by default is when you don't specify this flag here, it's automatically set to bin, which is binary. So if we create something like that, as you guys have seen before, we're going to get this hello world set up with a cargo toml. And it's pretty straightforward, and we saw how we can use other Rust files and all this other stuff. But what about if we did cargo new and instead used lib? We'll just call it some lib. What does that look like? Well, when you generate a lib, you get a lib rs instead of main, and it comes with test configurations to show you how to write tests in Rust. Now, what is lib? Well, cargo supports binaries and libraries, and when you use cargo new, as you can see by that flag, you can specify either. A lib is designed for you to create SDKs and things of that nature, and reusable code that you can share and import into other applications. So think of it like a library that you build once, and then you might have like 10 or so applications that are all using that library. You don't want to go into those 10 applications and change the code in each of those things. You better just change it in one location, upload a new library, and then those applications can just increment their version number, etc. So that's what these look like. Now, really quickly, I'm going to take that out for now, but really quickly, I want to mention that when you are developing locally, especially with a library, actually with a binary and library, you're obviously creating crates like we talked about before. And most of the time, when you're importing a crate, it's going to come from a site called crates.io. And it looks like this. This is where all the crates that are public to the Rust community are located. Now, there are crates out there that you can use that aren't on here. Like you can get them from GitHub, you can import them from pretty much anywhere that has any kind of crate registry or has the source files ready for download. But this is the public cargo crate registry. And you can see in here a ton of stuff that we've used. There's RAND in here. Basically, I would say most of the stuff you're going to use in your application can be found down here. And there's even stuff for crypto and network programming, all these different things. So check out crates.io when you get a sec. But when we're developing locally, you can actually use a local library inside your binary, which is kind of cool. So I'm going to show you guys how to do that. So for starters, let's declare a public function here. We'll just call it like what's up. And these are going to be pretty simple. I'm just going to print line what's up. And then let's also create another Rust file in this library called some libfunctions.rs. And we'll add another public function that just says nothing much. And as you can probably guess, we're going to print nothing much. And now, as we saw before with a binary, it works the same way for importing Rust files. So with lib, we're going to have this pubmod some lib functions. And now that's going to pull in any additional Rust files, which in our case is called some lib functions, into the main librs. And this is going to be the crate root for a library. And so if you had more than one library you want to import, like you would just obviously list them all like this. And you can also just declare functions right in here. Now, once you've done building your library and you want to use it in your local binary, there's nothing else that you have to do besides that in a basic sense. In your binary, however, we're used to declaring our dependencies here in cargo toml. But like, what do we call this thing? Do we just say like some lib? Well, yeah, but the import statement looks a little bit different here. So instead of just adding like a version or something, instead we're going to go like this. We're going to say path inside curly brackets, go back one directory, and it's going to be some lib. And now that's enough in our cargo toml of our binary to actually import the local library that we have. An alternative way to write this is you can do this, and you can just do dependencies.somelib. That's perfectly acceptable too. We're going to go with this method for now. So save that, and then in your binary, in main, we want to use those functions. So we have to import those. So we're going to use some lib, and we're just going to import all of it. And we're going to use some lib functions. We're going to import all that. And then we're just going to run those functions. What's up? Nothing much. And let's go into our binary and do a cargo run. And as you can see, we get our outputs. Beautiful. Now, why did I show you guys this? Well, there's a couple of reasons. First of all, this is how libraries are built in Rust and in Cargo. And any of the stuff that you import in your binary, like in your cargo toml, there's a good chance that it's going to be a lib created in Cargo using the same method that we just did. And that's what all these dependencies are. And we talked about crates.io and they can come from GitHub, wherever. But this is how developers do libraries in Rust. And being able to import it locally and stuff like that is really helpful for testing and debugging locally before you push up a new release of your library. So let's look at an example here in practice.
It's kind of difficult to know when should you put your own code though, when you're building the library. I guess I understand the logic, which is pretty similar to all the other languages, to JavaScript and Python mainly, which is you have a package manager, which is in Node, is the npm, and Python is the virtual environment with the side packages in the lib folder. So it's pretty much the same structure, but the only difference here is that when you're creating your own library, you should put on that in the same place. And in Python or in JavaScript, usually what I do is create a utils folder or something like that, or not even create folders, just put all the code in one file and then import the file into another one. So I'm not sure yeah, there's something to think about when to create your own libraries and put there instead of just creating functions on other files and then importing those functions.
Practice. This is the Solana source code. If you guys don't know what Solana is, it's a cryptocurrency network designed with proof of stake. And there's a number of different caveats to that, and there's a number of different advantages and disadvantages to it. But in a nutshell, this is a really, really, really fast blockchain. And this is their source code on GitHub. I'll put the link in the description, but it's Solana Labs. And you can see I've got it actually downloaded here, and I've opened it with VS Code. And now this thing's a beast, right? Like this is a monster. There's a ton of stuff in here. There's shell scripts, there's all kinds of programs. But if you start peering through it a little, I encourage you to do so because it's all written in Rust. You can open this SDK folder, and we can actually see a lot of stuff in here. And we go to source. What do we find? librs. So this is how Solana is using librs. And you can see that, just like we did, they're pulling in all of these modules. And you can see these listed here in the source folder. They're all Rust files. They're all centralized into this library and accessible by importing this stuff. And so the developers at Solana are building all these different functions and structs and all this stuff to build, and even traits and everything we've covered, to build out libraries that the Solana blockchain is then going to use in its binaries. So take a look at this. It's pretty cool. But as you can see, like this is what we covered here. And
I think I'm gonna look at this later. I think I remember downloading this. Maybe I still have here somewhere when I was gonna do the Solana stuff. And there's so much shit here. Start to yeah, maybe I delete it later. I'll probably delete it because I did it. I probably have a file on the virtual machine, but I'm too lazy to open that. Maybe later I will, but it's not that big of a deal. I can just download again. Yeah, I think reading the source code later after I watch a bunch of videos is gonna be good to understand how people actually code, uh, which is something that I did on all the other languages as well. Usually, I remember downloading some library and then going over the source code for a long time to understand how everything works and how people that actually understand and are probably good at the language do things.
and all this stuff is available to Solana. And then you can see there's some macro declarations and stuff, things we haven't covered yet. And then there's a test. So now you guys know how to build libraries in Rust and in Cargo. And if you even want to experiment with publishing them to either GitHub or to Crates.io, whatever you want to do, by all means. Hey everybody, and welcome back. Today we're going to be talking about some alternatives to functions in Rust, such as macros and closures. So we've used macros a lot already. In fact, here's one right here. Print line, exclamation point, that's a macro. We can also do this. That's a macro. Anytime you see this exclamation point, that's usually a macro. And you can see that this particular theme I've got in Visual Studio Code will populate it as yellow. What's happening here is this is actually its own sort of function that when it's compiled by Rust, it will write other code. So like when you have a function that's defined like this one here, like this what's up function, this is explicitly laid out and compiled by Rust as is. That's why you have to provide data types when you pass variables in. When you return stuff, you have to provide data types. That's because this is all explicit and Rust reads it as such. However, when you use macros, Rust does a lot of like taking a look at how you're using them and what values you're passing in and things like that, and it like automatically creates code that's then compiled as part of your application. So what does that look like? Well, we've got the vector macro up here that we've seen a few times already. So let's just write that out here in raw form. We'll see what this looks like. And again, just so you know, I'm in the sum lib library from the last tutorial because typically, like we saw with the Solana source code last video, you want to put your macro definitions in some kind of library. So this is how you create a macro. You can use this macro export annotation, and then this keyword macro rules, which is actually another macro, oddly enough, and we'll call it vec because we're gonna just create the vec macro. And what this looks like is kind of tricky, so I'm gonna type it out and then we'll break it down. So in here, we're gonna have this parenthesis, $, another parenthesis, $x, dxpr, comma, asterisk, and then that's going to return inside the curly braces, more curly braces, which is a scoped block. And I promise I will go through this. It's gonna be a little bit to unpack it first. We'll create a new temporary vector, and then we're gonna generate some code here that's gonna just do temp vec push. And it's gonna be that x key. And that's gonna turn one once, and we'll return temp vec, and of course we need a semicolon there. So that right there is how the vec macro is written. Now there's a lot happening here, so I'm gonna copy this and we're gonna walk through it all step by step. So first things first is we're gonna make this macro available elsewhere. It's in our lib folder, it's in our lib.rs file. So we're obviously gonna be importing this just like we saw we did with the what's up function, with the nothing much function. We want to make this macro available to the rest of our program, or any program that imports this library. So that's what this is doing. Now here, we're gonna actually use macro rules to establish the name of the macro. Macro rules tells us that this thing is a macro, and here's the name, and then we enter the curly brackets. Sweet. So now once we get into the curly brackets, this is where the complicated stuff starts to occur. Like you can see what are all these parentheses and $, like asterisks, what is going on? I'll try to explain this as simply as possible. First off, we're gonna match any Rust expression, and that's occurring here. This is representative of any Rust expression that could possibly be passed in. So that's represented by that. And at the same time, on the same line, we're going to allow one or more of them.